Space isn't calm, it's a storm of creation. Across the universe, galaxies ignite like engines burning through raw hydrogen to forge every atom of matter that exists. They spin, collide, and recycle the ashes of dead stars into new generations. Every element in your body, carbon, oxygen, iron, was manufactured inside one of these colossal machines. But galaxies are not supposed to behave like this. Some are birthing stars at impossible rates. Others have gone silent long before their time. The laws of physics say these systems should have collapsed or faded billions of years ago. Yet they're still burning, still creating. Something in the cosmic machinery is refusing to die. When I first saw deep field images from the Hubble telescope, it felt like looking at a wall of galaxies stretching forever. Each one was a furnace, a world builder, a factory where gravity and time forged existence itself. There are trillions of them. Spirals, dwarfs, ellipticals, each with a different design, a different rhythm. Some roar with violent black holes at their cores, others glow softly in the dark, quiet but alive. What if galaxies are not just collections of stars, but the universe's way of engineering complexity, the machines that turn chaos into light? To understand who we are, we have to open one of these engines and see how the cosmos builds. The stars may flicker, but the galaxies, they are the reason anything exists at all. What exactly is a galaxy? The question sounds simple. A galaxy is a collection of stars, gas, dust, and dark matter bound by gravity. But that definition doesn't come close to the truth. A galaxy is not just a cluster of objects. It's a living process, a machine running across billions of years. It takes in raw hydrogen, compresses it into stars, and uses those stars to create everything else from iron to life. Each galaxy is a feedback loop between chaos and balance, constantly reassembling itself from the debris it produces. If you could see one up close, it wouldn't look calm. The spiral arms would churn like storm fronts, clouds of gas collapsing into brilliant newborn suns, while supernovae tear others apart. Radiation flows like wind. Magnetic fields twist through space. Rivers of dark matter anchor the entire structure in place. From afar, a galaxy looks like a perfect pinwheel, but inside it's closer to a hurricane powered by gravity. What's stranger is that galaxies shouldn't even be able to stay together. They spin so fast that the visible matter alone can't hold them. They should fling themselves apart. Yet they don't. Something unseen, something we now call dark matter, provides the extra gravity that keeps them intact. Without it, there would be no structure at all, no spirals, no stars, no us. Every galaxy is both an experiment and a miracle, a cosmic engine learning how to sustain creation. And somewhere in one quiet arm of one spiral, our own story began. Stars may light up the universe, but galaxies are what keep it alive. If stars are the sparks, galaxies are the furnaces that feed and shape them. Every atom that burns inside a star, every molecule that will one day form a planet, begins its journey within a galaxy's invisible frame. Galaxies are not just containers of stars, they are the reason stars can exist at all. Without them, the universe would be a thin, endless fog of hydrogen too diffuse to ever ignite. Inside each galaxy, gravity weaves order from chaos. Gas and dust spiral inward, collapsing into dense knots where new suns are born. Those same stars will later explode, throwing heavy elements back into the galactic sea, enriching the fuel for the next generation. This is the true cosmic economy, an endless cycle of birth, death, and renewal, driven not by individual stars but by the galaxies that host them. When astronomers simulate the universe without galaxies, the result is empty. No structure forms, no planets emerge, no chemistry unfolds. Galaxies are the bridges between the early chaos and the complexity of life. They control how fast stars are made, how long they live, and what elements they leave behind. They are not the background of creation, they are its architects. If stars are the notes, galaxies are the symphony. Every rotation, every collision, every flash of light is part of a larger composition, the one that built us. No two galaxies are ever the same. Some spiral gracefully, their arms glittering with newborn stars. Others are swollen and red, their fires long extinguished. A few are so chaotic they look like frozen explosions, shattered fragments caught mid-motion. The diversity is staggering. Every shape, every colour, every size tells the story of a different life. Spiral galaxies like our Milky Way are the architects of order. Their swirling arms act like cosmic factories, compressing gas into bright clusters of young stars. Elliptical galaxies, by contrast, are ancient giants, smooth, spherical and silent. They are filled with old stars, their gas long consumed or blown away. Then there are the irregulars. Distorted, asymmetrical, born from violent collisions that tore their symmetry apart. Some are dwarves with only a few million suns, while others stretch hundreds of thousands of light years across. When I look at images from telescopes like Hubble or Webb, it feels like standing in a cosmic zoo. Each galaxy a living organism evolved by time and gravity. Some are young and restless, still forming stars at furious rates. Others drift quietly, fading into the background of space. And yet they all follow the same invisible blueprint. Rotation, feedback, balance, renewal. This diversity isn't random. It's the story of how the universe learns to build. From tiny irregular clumps in the early cosmos to vast spirals, today galaxies have evolved the way life does through collision, adaptation and time. Every form we see is a different answer to the same question. How can matter keep creating light? The galaxies we see today are not what the universe began with. In its earliest moments, everything was chaos, clouds of hydrogen and helium drifting through a darkening cosmos. No stars, no structure, no light. Then, within a few 100 million years, the fog broke. Tiny galaxies began to flicker into existence, compact and fierce, burning through their gas faster than physics thought possible. They were small, turbulent and unstable cosmic fires learning how to control themselves. When the James Webb Space Telescope peered deep into that era, it found galaxies so bright and massive that they defied every prediction. Some were already mature, forming stars at rates hundreds of times greater than the Milky Way does today. It shouldn't have been possible, there hadn't been enough time. Yet there they were, already spinning, glowing, structured. The universe, it seemed, had built its engines far earlier than we imagined. As billions of years passed, those early fragments collided and merged. Small galaxies joined to form larger ones, their stars mixing their gas, reshaping into spirals and disks. The cosmos evolved like a living organism, each generation learning to regulate its energy better to balance creation and destruction. Slowly, the wild chaos of the early universe settled into the vast, graceful structures we see now. Every galaxy, no matter how ancient or distant, carries that history in its shape. The spirals, the ellipticals, the dwarfs, they are fossils of time itself, snapshots of the universe, learning how to build complexity. When we look across cosmic time, we're not just seeing what galaxies were, we're watching the universe invent itself. Our galaxy is a machine running in perfect silence. From the outside, the Milky Way would look like a glowing whirlpool, 100,000 light-years wide, its arms coiling around a bright center. But inside, every atom is moving stars orbiting at hundreds of kilometers per second. Gas clouds, collapsing radiation spilling from newborn suns. It's not a still picture. It's a living process, and we are part of it. The Milky Way formed from countless mergers of smaller galaxies, each collision feeding it more fuel and momentum. Over billions of years, those fragments assembled into the grand spiral we call home. Its disk contains more than 200 billion stars orbiting a black hole 4 million times the mass of the Sun. Around those stars circle billions of worlds, some rocky, some frozen, some may be alive. Every second, somewhere in the Milky Way, a new star ignites. Somewhere else, another dies, scattering its elements back into the galactic sea. To us, it's the night sky, familiar, eternal. But from a cosmic perspective, the Milky Way is only one iteration of the universal engine following the same pattern seen in every galaxy across space. Gas falls inward, stars are born, elements accumulate, energy escapes. It is the heartbeat of matter itself. When I think about our place in this immense machine, I imagine the solar system as a single spark inside a rotating forge. Everything we are, every breath, every heartbeat is powered by this galactic engine. The Milky Way isn't just where we live, it's what we're made of. Curiosity began with a question as old as sight itself. What are those distant lights and how far do they go? For thousands of years we mapped the heavens by hand, believing the stars were painted onto a single cosmic dome. But curiosity refused to stop there. It built telescopes, measured parallax, and broke open the illusion. The sky wasn't a ceiling, it was depth, and hidden within that depth were galaxies, billions of them receding into forever. In the 20th century, astronomers turned curiosity into cosmology. They measured how galaxies move, how their light stretches as space expands. They found a pattern. The farther a galaxy lies, the faster it races away. That discovery, Hubble's law, proved the universe itself was growing. Every observation since has added another layer to that realization. Redshift surveys mapped the cosmos in 3 dimensions. Supernovae traced its acceleration. Cosmic microwave radiation revealed its birth. Piece by piece, curiosity assembled a story that stretched from the first second of time to the galaxies still forming today. And yet every discovery opens another question. Why is the universe expanding faster than it should? Why do galaxies rotate too quickly to be held together by visible matter? Why do their centers hide black holes of unimaginable mass? Curiosity gave us the tools, but not all the answers. Still, that's the beauty of it. Every measurement, every image, every spectrum is a conversation between humanity and the universe. The more we learn, the deeper the mystery grows, and the galaxies keep whispering their answers across the void. Everything we see, everything we touch began as something invisible. A few minutes after the Big Bang, the universe was nothing more than hydrogen and helium, too simple to build stars, too empty to create life. Yet somehow those 2 elements learned to assemble worlds, oceans, and minds. The key lies in one question. How do galaxies turn simple gas into complexity? That question sits at the heart of modern cosmology. It bridges physics, chemistry, and biology into a single narrative of creation. Galaxies gather the universe's raw material, ignite it into stars, and through those stars manufacture all the heavier elements. Carbon for life, oxygen for breath, iron for blood. All of them are recycled stardust forged inside the galactic engine. Without galaxies, the cosmos would have remained a sterile cloud, silent and cold. But this process is far from peaceful. Galaxies are turbulent machines always balancing between creation and destruction. When too many stars form at once, their radiation blows away the gas, shutting down the engine. When too few form, the galaxy fades, unable to sustain its light. Somewhere between those extremes lies the equilibrium that makes life possible, a rhythm tuned by gravity feedback and time. When I look at galaxies now, I don't just see distant collections of stars. I see the story of matter teaching itself to build. From simplicity to structure, from chaos to chemistry, galaxies are the reason the universe learned how to make itself alive. The story we're about to follow begins not with stars, but with darkness. For hundreds of millions of years after the Big Bang, the universe was invisible, filled with hydrogen gas so dense it swallowed every trace of light. Then something changed. Gravity began to pull that gas into clumps, and the first sparks of starlight pierced the cosmic fog. Those sparks joined together, forming the first galaxies, the engines that would reshape everything that came after. This is the journey we're taking, from the first cosmic dawn to the galaxies that now span the night sky. We'll watch the universe learn how to build, fail, and build again. We'll follow gas clouds as they collapse into stars, trace the birth of heavy elements, and see how those elements become planets, oceans, and eventually life. Every step we take will be a layer in the same grand machine, the galactic engine. But to understand how it all began, we have to travel back to when nothing had yet taken form. Before spirals, before clusters, before black holes. A universe still cooling, waiting for structure to emerge. Somewhere inside that quiet expanse, gravity was writing the first blueprint for creation. And once the first galaxy took shape, the darkness would never return. There was a time when galaxies did not exist and the universe was more perfect and more dead than it will ever be again. Matter was spread almost evenly, a smooth fog of hydrogen and helium cooling as space expanded. No stars burned, no planets formed, no structures broke the symmetry. By the rules of physics, that near perfection could have lasted forever. But perfection is fragile. Tiny ripples in density, differences of about 1 part in 100,000, began to grow under the pull of gravity. Regions just slightly denser than their surroundings started to slow gathering matter, as the rest of space continued to race outward. In the faint glow of the cosmic microwave background, we can still see the fingerprints of those first imperfections. This was a universe without galaxies, yet already pregnant with them. Invisible halos of dark matter were forming, laying down the scaffolding on which everything else would be built. Gas fell toward these unseen wells like rain drawn to valleys, heating and swirling as it collapsed. No forges of light had lit up yet, but the blueprints were already written into gravity itself. When I imagine that era, I do not see emptiness. I see a cosmos balanced between smooth and structured, holding its breath for the first sparks to ignite. The moment a single cloud of gas became unstable enough to fall in on itself, the age of darkness began to end and the age of galaxies began. Space should have been featureless. After the Big Bang, the laws of physics produced a universe almost perfectly smooth, with matter spread so evenly that nothing should have ever clumped together. Almost. On scales far larger than galaxies, tiny ripples in density lurked inside that primordial fog, slight overdensities and underdensities like the faintest wrinkles in an otherwise flat sheet. Those wrinkles were born from quantum fluctuations stretched to cosmic size during the universe's first fraction of a second, frozen into place as space expanded faster than light. To the naked eye, that young universe would have looked identical in every direction, but to gravity those tiny differences were everything. Regions just a little denser pulled slightly harder, gathering more matter, becoming denser still. Over millions of years, the contrast grew. The rich got richer, the poor grew emptier. What began as a 1 in 100,000 bump slowly inflated into the skeleton of all future structure. The pattern of those fluctuations is still visible today as a mottled glow in the cosmic microwave background, a baby picture of the universe before the first star ignited. When I look at those maps, I don't see noise. I see seeds buried in the dark, each one destined to grow into a halo of dark matter, a galaxy, maybe even a world with oceans and eyes. The entire cosmic web started as a whisper in the density field. From almost perfect uniformity, the universe chose imbalance, and in that imbalance, everything we know found room to exist. Dark matter is the frame the universe built everything upon, unseen, untouchable, but absolutely essential. Without it, galaxies would never have formed, and gravity would have had nothing to hold on to. The visible universe, all the stars, planets, and nebulae, makes up less than 5% of what truly exists. The rest, the silent majority, is invisible. We know dark matter is real, not because we can see it, but because of what it does. Galaxies rotate too fast for their visible mass to hold together. By every equation, their outer stars should have been flung into the void long ago, yet they stay bound, moving in perfect defiance of gravity's expectations. Something unseen provides the extra weight, a hidden halo surrounding every galaxy, shaping its motion, defining its structure. Simulations of the early universe reveal that dark matter formed the first scaffolding of cosmic architecture. While normal matter was trapped in a hot plasma, dark matter began to clump freely, creating invisible wells that would one day collect gas and light. It is the reason galaxies have their shape, clusters have their scale, and the cosmic web stretches in vast filaments across the sky. When I imagine the dark universe, I picture a ghostly framework, a web of gravity we cannot touch but live within, Every beam of light, every atom, every living thing hangs suspended on this hidden lattice. Without it, the cosmos would have expanded into silence, never finding the balance needed to build stars or us. At first, there were only clouds, immense weightless oceans of hydrogen and helium adrift in the dark. They stretched for millions of light years, so diffuse that a cubic meter contained fewer atoms than a breath of air. But inside the invisible wells of dark matter, gravity began to gather that gas. What had once been smooth started to fold. The first halos, the cosmic basins of creation, began to form. As the gas fell inward, it heated, compressing under its own weight until pressure and temperature rose high enough to resist further collapse. The universe was building the first blueprints of structure layer by layer inside these halos. Yet at this stage there was still no light. The gas was too hot to cool, too ionized to condense. The ingredients were there, but the recipe was incomplete. A cosmic furnace waiting for the spark. Over time, cooling channels emerged. Hydrogen molecules, rare but efficient, began to radiate away energy, allowing parts of the cloud to fall even deeper into the gravitational well. Within these collapsing knots, densities increased and temperatures climbed to tens of millions of degrees. Somewhere in that invisible depth, a single atom fused with another, releasing light for the first time. That flash marked a turning point, the end of the cosmic night. From clouds shaped by dark matter, the first halos became cradles of fire. Inside them, gravity and gas had finally found the balance that could build the first stars, and with them the first galaxies. The first stars were mistakes the universe refused to correct. They were far too big, far too hot, and far too short-lived to seem sustainable. Yet without them, nothing else could have followed. Born inside those newly cooled knots of gas, these primordial giants contained almost nothing but hydrogen and helium. No metals, no dust, no planets. They blazed with a purity we will never see again, pouring out light in a darkness that had never known it. These so-called first-generation stars were monsters. Many were dozens, perhaps hundreds of times more massive than the Sun. They burned through their fuel in only a few million years, living fast and dying violently. Their ultraviolet radiation carved bubbles in the surrounding gas, tearing apart molecules, heating the medium, and beginning to reionize the entire cosmos. For a brief moment, each one was a lighthouse in an ocean of night, announcing that the universe had finally learned how to shine. But their true legacy came in death. When these giants collapsed, they did not fade gently. They detonated as titanic supernovae or even more exotic explosions, forging the first heavy elements, carbon, oxygen, silicon, iron, and hurling them into space. The pristine gas inside their halos was no longer pure. It had been salted with the ingredients for complexity. When I picture those first stars, I see them not as stable engines but as ignition switches. They lit the furnaces that would follow. Their brief, furious lives transformed dark matter halos and cold gas clouds into the first working galaxies, luminous workshops where the universe could begin building everything else. Proto-galaxies were not the elegant spirals we see today. They were bruises in the fabric of space, small lopsided clumps of stars and gas thrashing inside dark matter halos. Freshly enriched by the deaths of the first giant stars, their gas was turbulent, torn by shock waves and bathed in radiation. Instead of stable disks, they looked like glowing knots, half-formed and overworked, trying to run before they had learned how to walk. Inside these primitive systems, star formation was reckless. Gas collapsed wherever it could, igniting clusters of new suns that blasted their surroundings with light and wind. Supernovae went off in rapid succession, blowing holes in the gas, ejecting material back into intergalactic space, and sometimes nearly unbinding the entire structure. A single burst of star formation could both build a proto-galaxy and almost destroy it in the same breath. It was as if the universe were testing how far it could push gravity before the whole experiment fell apart. These early fragments merged constantly. One clump would fall into another, their dark matter halos fusing their stars, passing through like ghosts, while their gas slammed together and reignited starbirth. Each collision changed everything: mass shape, rotation, chemistry. No proto-galaxy had time to settle. They lived in a permanent state of upheaval, stitched together by chance and gravity. Yet in that violence, a pattern was emerging. With every merger, with every cycle of collapse and explosion, these chaotic clumps grew larger and more organized. The universe was slowly refining its design, turning unstable firestorms into the first recognizable galaxies. From these small, violent ancestors, the majestic spirals and vast ellipticals of today would eventually descend. Galactic collisions look like disasters, but they are really assembly lines. When two proto-galaxies crash together, it seems as if gravity has lost control. Stars flung into long tidal tails, gas clouds, shredded shapes torn apart. Yet on larger scales, these violent encounters are how the universe builds bigger, more capable systems. Every merger takes small, unstable clumps and welds them into something larger, heavier, and more organized. What looks like destruction from one angle is construction from another. As the dark matter halos combine, their gravitational wells deepen, giving them more power to hold on to gas. That extra grip changes everything. Instead of losing their material to space, these merged systems can keep more of it, feeding longer, more sustained periods of star formation. Gas streams along the new gravitational contours funnel toward the center, where it condenses into dense clouds and ignites new stars. Collisions that seem chaotic actually drive matter along a kind of cosmic assembly line, from diffuse gas to clumps to clusters of newborn suns. Over billions of years, this process repeats. Small halos merge into medium ones, medium into large, large into giants. Each step up the ladder creates galaxies with deeper potential wells, richer chemical inventories, and more complex internal structure. Without mergers, the universe would be stuck with a swarm of tiny flickering fragments. With them, it can build grand spirals, massive ellipticals, and intricate networks of satellites. When I watch simulations of these encounters, I no longer see only wreckage. I see conveyor belts of gravity passing material from one stage to the next. The universe does not assemble its galaxies gently. It hammers them together, collision by collision, until the glowing structures we see today finally emerge from the chaos. Before galaxies came, the universe was blind. After the first stars burned out, their light faded into an ocean of hydrogen, thin, cold, and dark once more. Astronomers call this era the Cosmic Dark Ages, a time when the universe existed but could not be seen. There were no galaxies yet, only invisible halos gathering matter in silence. The cosmos was full of potential waiting for ignition. Inside those halos, the chemical fingerprints left by the first stars began to change everything. Their supernovae had scattered traces of heavier elements, just enough to cool the gas faster to let it collapse again. Each burst of creation and destruction made the next generation easier to form. Slowly, the darkness began to crack. The first clusters of stars reignited, merging into larger systems, their radiation piercing through the cosmic fog. It was not a peaceful transition. The newborn galaxies flooded space with ultraviolet light, stripping electrons from atoms, reionizing the universe, and turning transparent what had once been opaque. The fog cleared, and for the first time light could travel freely from one end of the cosmos to the other. When we observe the ancient radiation today, we're seeing the universe at the moment it woke up. The Dark Ages ended not with a single flash, but with a billion small ones. Galaxies lighting their surroundings until the entire sky glowed. The cosmic night had finally broken, and the modern universe had begun. At first, galaxies had no shape, just clouds of stars colliding in chaos. Gravity was winning, but order had not yet arrived. Then something remarkable happened. The turbulence began to settle. As gas and stars orbited the growing centers of mass rotation took over, chaos found rhythm. And for the first time in cosmic history, the universe began to draw circles. The earliest galactic disks were fragile and thin, shimmering with young blue stars wrapped around dense, invisible halos of dark matter. They were not perfect spirals, yet more like warped sheets of light constantly twisted by gravity and collisions. Each rotation took hundreds of millions of years, but with every turn the galaxies became smoother, flatter, more defined. Rotation was the great organizer transforming clouds into architecture. These disks changed how galaxies lived. Gas streaming along their arms was compressed into stars. Shock waves rippled outward like waves in a pond. Where the gas was thickest, new clusters formed. Where it thinned, darkness returned. The cosmic workshop had learned efficiency, turning chaos into structure, turbulence into beauty. When I imagine those first disks glowing against the deep black of early space, I think of the moment a storm learns to dance. The universe had built its first stable machines of light. They would endure for billions of years, refining their form until they became the grand spirals we see today. Elegant, balanced, alive. Galaxies were born in violence, and that violence never truly stopped. Even as the first disks formed, they churned with turbulence, vast storms of gas moving at hundreds of kilometers per second, twisting and colliding in every direction. Gravity pulled the gas inward, pressure pushed it back out. The entire structure shook, a furnace barely holding itself together. Out of that chaos came the first stable patterns, but not by chance. Something invisible was helping keep order. Magnetic fields, weak but everywhere, threaded through those newborn galaxies. As charged particles moved through the plasma, they generated fields that grew stronger with every rotation. These invisible lines of force guided the flow of gas, channeling it into filaments and spirals, shaping where stars could form. Without them, the gas might have scattered too quickly. With them, galaxies could breathe, compressing, expanding, and settling into equilibrium. Turbulence, once the enemy of structure, became its sculptor. Shock waves from supernova stirred the gas, mixing heavy elements from dead stars into new clouds, while magnetic tension dampened the chaos just enough to keep the system intact. The balance was delicate. Too much turbulence and the galaxy tore itself apart. Too little, and it stagnated, star formation ceasing altogether. When I think about those forces, gravity, magnetism, turbulence, I see them not as separate players, but as instruments in the same cosmic orchestra. Each note of motion, each field line, each wave of pressure contributed to the same outcome, a universe that learned how to organize fire. When we built the James Webb Space Telescope, we expected to see baby galaxies, small, clumpy, just learning how to shine. Instead, the deeper it looked, the more it broke our expectations. In a universe only a few 100 million years old, Webb found compact galaxies that looked grown, massive, dense, bright. They were like overgrown infants, far too developed for their age. According to our best models, there simply had not been enough time to assemble that much mass, light and structure. Yet there they were, burning in the dark as if the universe had skipped a few chapters. Some of these systems pack tens of billions of stars into regions smaller than the Milky Way's central bulge. Their light is stretched into deep infrared by the expansion of space, but once decoded, it tells a shocking story. Furious star formation, enriched gas, and in some cases hints of heavy elements that should have taken many generations of stars to produce. The cosmic clock says too early. The galaxies reply, we are already busy. When I first saw those Webb deep fields, tiny patches of sky filled with ancient red smudges, it felt like reading a diary that starts in the middle. The opening pages of galaxy formation seem to be missing. Either our understanding of how fast matter can collapse and cool is incomplete, or something about gravity, dark matter, or feedback is more efficient than we thought. The universe appears to have rushed its first designs, building fully functional galactic workshops almost as soon as it could. Maybe that is the real surprise. Not that galaxies exist so early, but that the cosmos wastes no time once the conditions are right. The moment gravity and gas had the chance to cooperate, they did. And the first engines of creation switched on at full power, long before we expected the workshop to even open. The galaxies that James Webb revealed were not supposed to exist, at least not yet. Our simulations predicted that in a universe less than 500 million years old, galaxies should have been small and chaotic, more like scattered sparks than structured worlds. But Webb showed something different. Massive compact systems already rich in stars and metals glowing like mature galaxies billions of years too soon. Scientists called them overgrown infants. Their light tells of furious star formation so intense it could build the mass of the Milky Way in a few 100 million years. That would require gas to fall inward with impossible efficiency and gravity to work faster than our equations allow. If that's true, then either our understanding of dark matter is incomplete, or the laws that govern early cosmic cooling are more generous than we thought. These galaxies shouldn't have had time to form supermassive black holes, yet some already host them. They shouldn't contain heavy elements, yet their spectra whisper of oxygen and iron. It's as if the universe found a shortcut to complexity, skipping the slow build-up and leaping straight into the golden age of starbirth. When I think about this, I imagine the cosmos as an impatient artist sketching galaxies in bold strokes before refining the details. We used to believe time was the limiting factor in creation, but maybe in those first moments the universe didn't wait for permission. It simply decided to begin. There was a time when the universe burned at its brightest. Astronomers call it the cosmic noon, the era when galaxies produce stars at their fastest rate around 10 billion years ago. The sky then would have glowed with the light of 1 trillion suns being born every second across the cosmos. Galaxies collided, merged and fed on cold gas from the cosmic web like lungs breathing in starlight. The universe was running a fever of creation. Star formation rates soared to 100 times higher than today. Vast clouds of gas collapsed under their own weight, igniting dense clusters that would one day become the hearts of spiral arms. Supernovae erupted in waves, recycling elements and stirring galactic winds that blew thousands of light years into space. It was chaos, but it was productive chaos. The universe at full throttle building structure faster than destruction could tear it down. At the same time, the seeds of restraint were forming. Supermassive black holes began to flare as quasars flooding their host galaxies with energy. Their radiation heated the surrounding gas, slowing starbirth and beginning the long decline that would follow. The cosmic factory was self-regulating, learning not to burn through its fuel too quickly. When I imagine that age, I see the universe as a forge glowing white-hot, too bright to last but necessary to define everything that followed. We live in its aftermath, in the cooled embers of that creative storm, orbiting stars born from the peak of the cosmic noon. Galaxies are not isolated islands, they are breathing ecosystems. Gas flows in stars, ignite elements are forged, and then those stars die, returning their materials to the galactic sea. It is a cycle as ancient as the universe itself. Every spiral arm, every glowing nebula is just one phase of that endless respiration between gravity and light. When massive stars explode, they don't just end, they give back. Their supernovae scatter carbon, oxygen and iron across thousands of light years, enriching the interstellar medium. Shock waves compress nearby gas, seeding new clusters of stars. In turn, those newborn stars send out winds and radiation that sculpt their surroundings, feeding energy back into the galaxy's body. The process never stops: inflow, ignition, feedback, renewal, but galaxies also inhale. Streams of cold gas flow in along cosmic filaments, refueling the system and sustaining its life for billions of years. Without this steady supply, the fires would fade. The universe would cool into silence. Instead, galaxies recycle. They pull in, they release, they adapt. In every rotation, they learn to balance creation with exhaustion. When I look at images of glowing galactic cores, I don't just see light. I see metabolism. The Milky Way is not a machine of metal and dust. It's a living network constantly regenerating itself from its own ashes. Every breath it takes carries us with it. Atoms recycled through generations of stars until they became the elements of life. Galaxies are social creatures. They gather, collide, and form sprawling cities of light bound together by gravity. From a distance, these clusters look serene. Hundreds, or even thousands of galaxies floating in a sea of dark matter. But inside, the scale of interaction is almost violent. Galaxies tug at each other, stripping gas, exchanging stars, and stirring the vast hot plasma that fills the space between them. The cosmic web connects them all. Along invisible filaments of dark matter, galaxies stream toward one another, assembling at the nodes like travelers converging on a glowing metropolis. The largest of these gathering superclusters stretch for hundreds of millions of light-years, their gravity shaping the motion of the universe itself. They are the architecture of the cosmos, a grand network of intergalactic civilization built not by life but by physics. Yet this social gravity comes at a price. Inside dense clusters, galaxies compete for survival. Their halos overlap, their gases stripped away by the hot intercluster medium, and star formation begins to fade. Some grow massive through cannibalism, consuming smaller neighbours. Others are quenched, reduced to quiet red shells of old stars. The more connected galaxies become, the more fragile they are. When I see these clusters in telescope images, I think of them as the cities of the universe. Bright, crowded, full of energy, but destined to decay. Gravity built them to last for billions of years, yet even they will one day drift apart as cosmic expansion accelerates. The universe builds communities, but it never lets them stay still. At the center of nearly every galaxy hides a paradox, a supermassive black hole, millions or even billions of times the mass of the Sun. It is the most destructive object in existence, yet without it, the galaxy around it might never have formed the way it did. These black holes do not merely consume, they organize. Their gravity shapes orbits, their energy sculpts gas, and their feedback decides when and where stars can be born. In a universe built on creation, these are the engines of restraint. When matter falls toward a black hole, it does not vanish quietly. Friction and magnetism tear it apart, heating it until it shines brighter than all the stars in the host galaxy combined. These are active galactic nuclei quasars visible across billions of light-years. Their radiation blasts outward, pushing gas away, shutting down star formation before the galaxy burns through its fuel. It's a brutal kind of balance. Creation throttled by destruction to ensure survival. The correlation between black hole mass and galactic bulge isn't coincidence. It's evidence of partnership. The heart and the body grow together, each feeding the other. As galaxies merge, their central black holes spiral inward, eventually fusing and sending ripples of gravitational waves across the cosmos. Even in silence, they leave their mark. When I think of these dark hearts, I don't see emptiness. I see the pulse of the universe, invisible, patient, essential. Every galaxy breathes around one as if tethered to a singular rhythm. To destroy everything and still make order from it, that's the quiet genius of the cosmos. Galaxies do not keep their shape forever. Every collision, every burst of star formation, every gravitational nudge leaves a mark. Over billions of years, these cosmic interactions choreograph an endless dance spirals, twisting into ellipses, disks thickening into spheroids, clusters of stars scattering like embers in slow motion. The shapes we see today are not static portraits, but snapshots in motion captured mid-step in a dance that never ends. Spiral galaxies are the most graceful of the dancers. Their arms wind outward, tracing the paths of density waves that ripple through rotating disks of stars and gas. They are engines of renewal, still forming stars, still glowing blue with youth. Ellipticals, by contrast, are the veterans. They are older, redder, and quieter, filled with ancient stars and little gas left to create new ones. Most ellipticals were born from collisions when two spirals merged, and their ordered disks dissolved into a turbulent sphere of light. Between them lies every variation: lenticulars with fading disks, irregulars torn by tidal forces, dwarfs drifting between giants. The diversity is the record of history itself. No two galaxies share the same past, yet all follow the same rule. Structure remembers motion. When I study their shapes, I don't just see beauty. I see memory frozen in geometry. The curve of a spiral arm, the smoothness of an ellipse, each is a record of gravity's handwriting over time. The universe may be chaotic, but in these forms it leaves traces of rhythm, as if even destruction must dance to the same cosmic beat. Magnetism is the quiet architect of the cosmos. It doesn't shine. It doesn't pull, yet its influence stretches between galaxies, threading the universe with invisible lines of force. For decades, astronomers ignored it, thinking gravity alone shaped the large-scale structure. But new observations revealed something astonishing. The cosmic web itself is magnetized. Even the vast voids between galaxies hum with faint magnetic tension, as if space were woven from an unseen fabric of energy. Within galaxies, magnetic fields guide the flow of gas-like rails in a stellar railway. They channel charged particles along spiral arms, sculpting nebulae and helping regulate where stars can form. On larger scales, intergalactic fields connect galaxies through filaments of plasma, transmitting cosmic rays across millions of light-years. These fields are weak trillions of times fainter than a refrigerator magnet, yet they control the motion of matter light-years across. No one is entirely sure where these fields came from. Some may have been born in the first instance after the Big Bang, amplified over time by motion and turbulence. Others might arise from the galaxies themselves, seeded by rotating disks and supernova explosions. Whatever their origin, they tie the universe together, linking structures that gravity alone cannot explain. When I imagine them, I see not emptiness between galaxies, but a vast woven tapestry, invisible, humming alive. The cosmos is not a void, but a loom, threading light and matter through magnetic strands. Even the silence of space carries a pattern. Every galaxy is an archive, a record of everything the universe has ever tried. Astronomers call it galactic archaeology, the science of reading history written in starlight. Each star carries clues about when and where it was born, its chemical composition, its motion, its age. By collecting these clues, we can reconstruct the life story of an entire galaxy, from its violent youth to its quiet middle age. In the Milky Way, telescopes like Gaia have mapped the motion of over 1 billion stars with exquisite precision. The result is a three-dimensional time machine. Streams of stars crossing the sky reveal ancient mergers when smaller galaxies fell into ours and were torn apart. Their remnants still orbit the galactic center, fossil trails of collisions long past. Every pattern of motion, every trace of chemical fingerprint is a page in the Milky Way's diary. Even the smallest details matter. A star rich in heavy elements tells of a birthplace in later generations after countless supernovae had enriched the gas. One pour in metals comes from the galaxy's youth when the cosmos was still raw. Together they form a gradient of time from the oldest halo stars to the youngest in the spiral arms, a cosmic stratigraphy of evolution. When I think about galactic archaeology, I picture astronomers as cosmic historians brushing away dust not from bones but from light. Each photon we capture carries a memory, a story written billions of years ago. The galaxies remember everything. We just had to learn how to listen. Light is the universe remembering itself. Every photon that reaches us has been travelling for billions of years, carrying a message from a time long gone. When we point our telescopes at distant galaxies, we aren't seeing them as they are, but as they were, ancient and young at the same time. The farther we look, the older the story becomes. Observation is not seeing, it is time travel. Each deep image of the sky is a layered archive of the universe's memory. The brightest points are nearby galaxies still alive and evolving. Behind them lie faint red smudges, relics from the first few 100 million years. The light from those galaxies has crossed expanding space, stretched and thinned by the motion of the cosmos itself. Some photons have been travelling since before the Earth existed, and yet after that impossible journey, they still find our eyes. In that sense, every act of observation is an act of resurrection. We are bringing the past back into the present, decoding the universe's diary one wavelength at a time. And as we look deeper, we realise something humbling. The light that tells the story is the same light that built us. The atoms in our bodies once absorbed and released this energy. Now we use it to trace our own beginnings. When I look at the sky, I no longer see stars or galaxies, I see memory in motion. The universe is not expanding into emptiness, it's expanding into awareness. Through light it remembers, through us it understands. There is no explosion when a galaxy dies, no final flare, no violent collapse. Instead, the light simply begins to fade. Over billions of years, the cold gas that once fueled new stars runs out. The great spiral arms, once bright with blue clusters, turn pale and red as young stars disappear and only the elders remain. The galaxy is not destroyed, it is exhausted. The engines of creation slow to silence. Astronomers call this quenching a quiet death written in colour. As the last reserves of gas are spent, gravity still holds the stars, but nothing new is born. Supernovae grow rare, the nebulae thin and vanish. The galaxy that once blazed like a furnace becomes an ember glowing softly against the night. Some are quenched by their own black holes, others by their environment stripped of gas, starved by the heat of surrounding clusters. To the eye, these galaxies still look magnificent, but their beauty is that of endurance, not youth. They are relics of a universe that once burned hotter symbols of a cosmos beginning to cool. The light they give off is old light photons emitted long ago, still crossing the dark. When I imagine them, I see the universe catching its breath, not dying but resting. The glow remains softer now, stretched thin by time, proof that even in silence creation lingers. A quenched galaxy is a ghost of what it once was. The spiral arms still trace their graceful curves, but their colour has changed, no longer blue with the fire of newborn stars, but rusted red like iron left in the rain of time. The gas that once flowed through those arms has vanished, stripped by radiation, swallowed by black holes or blown away by ancient winds. What remains are the elder stars glowing softly, their energy fading atom by atom. These are the silent spirals, the galaxies that have gone quiet. They no longer build, they only remember. Every orbit, every flicker of light is a whisper from the past. Inside them, the chemistry of creation has frozen. The massive, short-lived stars are gone. Only long-burning red dwarfs and dying giants persist. It is not darkness that follows. It is a deep, steady glow like the afterimage of a fire long extinguished. Astronomers once thought galaxies died in violence, but most fade this way slowly and peacefully, their light thinning like breath on glass. Their silence is not tragedy, it is stability. They have achieved balance, neither collapsing nor creating sustained, only by momentum. When I think about them, I imagine the universe at twilight, not the end, but the pause between chapters. These galaxies are monuments to time itself, reminders that even in stillness the cosmos endures. They may no longer sing with the voices of newborn stars, yet their quiet light still reaches us, carrying the memory of everything they ever were. Galaxies are not gentle creatures. Beneath their beauty lies hunger. Over billions of years they drift closer, drawn together by gravity, and when they meet they devour each other. The smaller one is torn apart, its stars stretched into luminous streams that wrap around the survivor like cosmic scars. Astronomers call it galactic cannibalism, a quiet violence that has shaped the universe from the beginning. The Milky Way itself is guilty. Even now it is consuming its smaller companions, the Sagittarius dwarf galaxy, the Magellanic Clouds, swallowing their stars into its halo. The evidence lies in rivers of light arcing across the sky, the remnants of galaxies already digested. Every giant we see today was built this way, through mergers and collisions, each act of destruction feeding creation. When two galaxies collide, their stars rarely hit each other. Instead, gravity reshapes them, flinging orbits into chaos, triggering waves of gas compression that ignite new generations of stars. The galaxies fuse into one brighter and more massive than before, a predator reborn as a creator. In time, even the scars fade, and what remains is a single stronger system carrying the memory of all it has consumed. When I look at images of colliding galaxies, I don't see violence alone. I see the cosmic instinct to survive, to grow, to continue building, even when it means tearing apart the old. The universe never wastes. Every swallowed galaxy becomes part of another, every destruction a reconstruction. In space, nothing is lost, only rearranged. Not every star belongs somewhere. When galaxies collide or drift through crowded clusters, millions of stars are thrown loose, stripped from their homes and left to wander between galaxies. These are the intra-cluster orphans, the unbound lights adrift in intergalactic space. They move through the darkness alone, too far from any galaxy to return, yet still burning, still shining. Astronomers first discovered them as a faint ghostly glow that filled the gaps between galaxies. It wasn't background light, it was starlight, the collective shimmer of the lost. Hubble and now Webb have traced these exiles, revealing tidal streams and diffuse halos that stretch for millions of light years. Some were torn free by gravitational tides, others by violent mergers. Each is a traveller carrying its element-rich legacy into the cosmic void. If you could stand in one of these clusters, space would not be black. The sky would shimmer with scattered stars, dim, pale, countless drifting without direction. These orphans no longer orbit a centre, they orbit the cluster itself, their light pooled into an invisible ocean of memory. When I think about them, I can't help but feel a strange tenderness. These stars are homeless, but not forgotten. Their glow still reaches us, faint but persistent. A reminder that even in the emptiest parts of space, beauty survives. The galaxies may have cast them out, but the universe keeps their light. Every so often, the universe remembers how to begin again. When two galaxies collide, their clouds of gas crash and compress, igniting sudden waves of star formation. These events are called starbursts, brief, furious resurrections that can outshine entire galaxy clusters. In a cosmos that seems to be slowing down, these moments of rebirth are reminders that creation never truly stops. A quenched, silent galaxy can flare back to life after a merger. Cold gas, once dormant, is shocked into motion. Vast regions collapse under gravity, birthing millions of stars in only a few million years. The galaxy glows blue again, a newborn dressed in an ancient body. Even after eons of quiet, one collision can make it young. Telescopes have captured these rejuvenations, galaxies twisted into surreal shapes, bridges of light connecting them, luminous knots where stars are forming by the thousands. It looks chaotic, but the chaos is fertile. The same violence that tears galaxies apart also gives them the energy to rebuild. When I see those images, I don't think of destruction. I think of breath returning to a chest thought still. Galaxies don't die easily. They rest waiting for the next encounter, the next spark. In every corner of the universe, the same truth plays out. Even in decline, the cosmos keeps finding reasons to shine. The universe is growing old. The bright blue galaxies of its youth have faded into shades of amber and crimson. Astronomers call this coming era the Iron Age, a time when the cosmos has forged most of the heavy elements it will ever make. The raw hydrogen that once fed the stars is nearly gone, consumed and transformed by generations of fusion and fire. What remains are the long-lived embers, red dwarfs faint and slow, burning their fuel with infinite patience. In this aging cosmos, star formation dwindles. New stars appear only rarely, born from recycled gas in the outskirts of surviving galaxies. The great spiral arms have dimmed, the interstellar medium has cooled. Black holes sit quietly at their centres, no longer feeding, just waiting. It is not death but weariness, a universe catching its breath after an eternity of creation. The chemical richness of space is complete now. Iron, nickel and carbon saturate the dust. Planets that form in this era are built from the ashes of billions of stars, dense and metallic, forged from cosmic memory. The young universe built light, the old one builds weight. When I imagine this Iron Age, I don't see sadness. I see endurance. The stars may fade, but they last. Some will shine for trillions of years, far longer than the universe has existed so far. The cosmos is slowing, yes, but it is also learning how to last. Darkness is not the enemy of the universe. It is what grows when light finishes its work. As the ages pass, galaxies exhaust their fuel. Their brightest stars die and their glow shifts to longer, redder wavelengths. The night between them thickens. Where once the cosmos blazed with newborn suns, it now smoulders with the fading embers of old ones. The darkness is not sudden. It is a slow tide rising around islands of light. One by one, the luminous giants vanish. The short-lived blue stars are the first to go, then the yellow suns, leaving only dim red dwarfs scattered through thinning gas. These small stars burn for trillions of years, but even they cannot last forever. When their fuel is gone, they cool into black dwarfs, dead stars invisible against the cold. Galaxies that once shone across millions of light years become collections of unseen remnants, their brilliance reduced to a whisper. In this deep future, black holes remain as the last active players. They swallow the final scraps of matter, growing heavier and more isolated as space expands. Eventually, even they will begin to fade, leaking their mass away in a slow drizzle of radiation. The engines that once shaped galaxies will evaporate into nothing, leaving only a thin bath of low-energy photons and particles spread across an ever larger void. When I think about that distant era, I do not imagine a violent end. I see a universe falling gently out of sight, its structures dissolving into memory. The darkness grows not as a sudden curtain, but as a soft blur, as if reality itself were exhaling its last light. Entropy is the quiet ruler of everything. It doesn't destroy, it spreads. Over unimaginable time, energy becomes evenly diluted until there are no gradients left to drive motion, fusion, or life. Galaxies fade, stars cool, and even light itself stretches beyond recognition. This is not an explosion or collapse. It is the slow perfection of balance, a universe reaching thermal peace. As expansion continues, galaxies drift farther apart, redshifting into invisibility. Photons lose energy, their wavelengths stretched until they can no longer be seen by any eye or machine. The last stars fade to black dwarfs. The last gas clouds evaporate and space itself grows thin and silent. The cosmic web unravels into isolation, every surviving island cut off from the rest by distance and time. Eventually only black holes remain, devouring what little matter still wanders near them. But even they cannot last. Over trillions upon trillions of years they will evaporate through Hawking radiation, returning their mass to the vacuum. The universe will become a sea of near absolute darkness, filled only with stray photons, neutrinos, and cold atoms drifting in infinite quiet. When I think about that ending, I don't see despair, I see serenity. The cosmos began in a blaze of chaos and ends in perfect stillness. Every atom, every flash of light, every galaxy's heartbeat has played its part in reaching equilibrium. In that final calm, entropy is not death, it's rest. The universe is not gone, it has simply completed its thought. Even after the light fades, something remains. The universe may fall silent, but silence is not the same as absence. In the endless darkness after entropy, the fabric of space will still tremble with quantum whispers, tiny fluctuations, ripples of possibility that never fully disappear. These are the echoes of creation, the same seeds that once grew into galaxies, stars, and life. Some cosmologists believe those fluctuations could one day spark new beginnings, small pockets of order rising out of perfect equilibrium, igniting new bursts of expansion, new universes. This cycle would continue, each cosmos born from the ashes of the last forever, exploring the limits of what existence can become. In that vision, creation is not a single event, but a rhythm. Expansion, cooling, silence, renewal. Even if that never happens, the echo's already here. It lives in the background radiation that still hums across the sky, a faint reminder of the first fire. It resonates in every atom that once belonged to a star, in every photon that still carries the memory of its birth. The universe has not forgotten how to make light. It just waits patient as gravity for the next chance to begin. When I imagine that moment, I see not an ending, but a heartbeat. One so slow it takes eternity to complete. The galaxies may dissolve, the stars may die, but the echo remains vibrating through the dark like a promise. The cosmos has learned how to rest, but not how to stop. We are made of everything that came before. Every atom in our bodies was forged in a star, every heartbeat powered by light, born billions of years ago. When we look into the night sky, we're not seeing something distant. We're seeing our own origins scattered across space and time. The galaxies are not out there. They are within us, written into our blood, our bones, our breath. The universe spent billions of years building the conditions for thought assembling complexity from chaos, until it could look back at itself and wonder. Through us it remembers. Through our telescopes and questions, it rediscovers what it once created blindly gravity-light life. We are the cosmos becoming aware of its own reflection, the memory of galaxies given a voice. And though the stars will fade, the act of remembering will not. Every observation, every image, every idea is a way for the universe to preserve its story a little longer. Even when the light is gone, its echo will linger in minds that once saw it. The galaxies built us to see them, to keep their memory alive after the last photon fades. When I think about that, I no longer fear the darkness, because in some way it was never empty. It is filled with everything that ever was and everything that ever loved to shine. The farther we look, the older the universe becomes. When astronomers capture the faint glow of distant galaxies, they're not seeing them as they are today, but as they were billions of years ago. Each photon of light is a traveller crossing cosmic distances to reach our eyes. A simple glance at a deep space image is in truth a glimpse into prehistory, a window through which the past still burns quietly alive in the present. It's a strange thought that light can outlive the worlds it came from. Some of those galaxies may no longer exist, their stars scattered, their shapes erased by mergers or time, yet their light continues carrying the memory of what once was. Telescopes don't just reveal the distant universe, they reveal its persistence. Every observation is an act of time travel, a way of touching the universe, not as it is but as it once dreamed itself to be. When astronomers speak of the observable universe, they don't mean the whole of existence, only the part that light has had time to reach us from. Beyond that invisible frontier, the universe continues perhaps endlessly. The boundary isn't physical, it's temporal, defined by the age of space itself. We are surrounded by a cosmic horizon, roughly 46 billion light-years away in every direction, a sphere not of matter, but of time expanding as the universe grows older. Everything beyond that horizon remains unseen, its light still travelling through the void. One day, eons from now, even nearby galaxies will slip beyond visibility as cosmic expansion pulls them away faster than light can follow. What we call the observable universe is really just our local bubble of time, a temporary window carved out by physics and chance. And within that fragile bubble we search for meaning, counting galaxies we were never meant to see. At first it sounds simple, count what you can see and multiply. But the universe doesn't make it that easy. Every telescope, no matter how powerful, sees only a fragment of the sky. What we capture are statistical samples, not a census. Some galaxies are hidden behind dust, others lie beyond our detection threshold. Even the faintest light may be drowned out by cosmic background noise. To measure everything, astronomers must rely on models, mathematics, and a little imagination. Each observation is a clue, not a conclusion. From a small patch of deep sky, scientists estimate how many galaxies should exist across the entire celestial sphere. But the universe is not uniform. Matter clumps and thins, voids stretch for hundreds of millions of light-years. A single deep field might represent one cosmic neighborhood, not the average of all. Counting galaxies, then, is not a matter of arithmetic. It's an act of inference, a way of sketching infinity with limited light. The deeper we look into the universe, the more deceptive it becomes. Light doesn't simply travel, it stretches, bends, and fades with distance. As space expands, the wavelength of that light grows longer, turning visible colors into red-shifted whispers from the ancient past. A galaxy seen as a tiny red smear might in truth be vast and brilliant, but its light has aged for billions of years on the way here. We see not reality, but its memory written in light. Even time itself plays tricks on what we observe. When we gaze across cosmic distances, we're witnessing events frozen in their youth galaxies forming stars, igniting worlds, taking shape long before Earth existed. The universe we map is not the universe of now, but a mosaic of moments scattered across time. Every image is both true and outdated, a fossil record of light still arriving from the deep. To study the cosmos is to accept this distortion, to see beauty through the slow lens of eternity. To count the galaxies is to measure the scale of everything. It's humanity's quiet attempt to outline the borders of the infinite. Each new telescope from Hubble to Webb pushes that frontier a little farther, turning specks of darkness into crowded seas of light. But this is more than science, it's an act of curiosity written into our nature. We are a species that wants to know what lies beyond the horizon, even when the answer threatens to break our sense of proportion. This cosmic census is still underway. Every observation adds another piece to the map, a faint dot here, a cluster there, until the invisible begins to take shape. What once looked like a handful of galaxies now appears as hundreds of billions, perhaps trillions. Yet even as our instruments grow sharper, the universe keeps receding, its edges running away faster than our reach. To count the galaxies is to chase light itself, knowing we can never catch it. Before we could count the galaxies, we had to realize there was more than one. For centuries, astronomers believed the Milky Way was the totality of creation, an enormous but finite system containing every star, every world, every mystery. Through their early telescopes, the universe looked like a glittering shell enclosing humanity at its center. The faint clouds they saw beyond the stars were puzzling, but harmless small smudges drifting inside the limits of our cosmic home. It was an age of certainty and confinement. No one doubted that our galaxy defined the universe itself. The heavens were vast but still local, a single luminous continent surrounded by eternal darkness. And yet in quiet observatories scattered across Europe, a few restless minds began to sense something off. The stars did not end cleanly. The sky refused to fit its own borders. In that discomfort, the modern universe was waiting to be born. For centuries, the mysterious spiral nebulae were among the most puzzling objects in the night sky. Through small telescopes, they appeared as ghostly swirls of smoke, delicate, faint, and impossibly distant. Many astronomers thought they were gas clouds within our own galaxy, perhaps nurseries where new stars were forming. Others suspected something more. Their shapes were too precise, their structures too grand to be mere wisps of vapor. Still without evidence, imagination remained confined within the Milky Way. The misunderstanding was easy to forgive. In an age before photographic sensitivity or modern optics, the universe revealed itself only reluctantly. Every observation was filtered through instruments too crude to see the truth. Even the brightest of the spiral nebulae, the one in Andromeda, showed no stars under the magnification of the day. It looked smooth, featureless, too far away to resolve. The idea that this faint spiral might be a galaxy like our own was as radical then as imagining an infinity of worlds is to us now. The telescopes of the 19th century were powerful for their time, yet painfully inadequate for the questions astronomers were asking. They revealed structure but not distance, beauty but not truth. Each new lens peeled away a thin layer of mystery only to expose another one beneath. The further they looked, the more the heavens blurred into haze. It was as if the universe were teasing them, allowing a glimpse of its design but never enough to understand its scale. Still, those crude instruments carried the first generation of explorers beyond myth. William Herschel, sweeping the sky with his massive reflectors, mapped thousands of nebulae and believed he was charting the Milky Way's borders. He thought he was measuring the edge of creation itself. Yet even his remarkable maps told a lie. The fog he saw wasn't the boundary of our galaxy, but the threshold of countless others. The universe had hidden its enormity behind glass and patience, waiting for sharper eyes to uncover it. Long before the age of a modern cosmology, many thinkers believed the universe must have an edge. The Milky Way, bright and immense, seemed to form a natural boundary, a shining wall separating existence from nothingness. Philosophers spoke of it as a kind of cosmic island, a vast yet complete adrift in an endless void. It was a comforting thought, a universe small enough to be grasped and a creation with a clear beginning and end. But nature rarely conforms to comfort. As telescopes grew stronger, that neat picture began to unravel. The Milky Way's edges blurred, stretching farther than any map could follow. Beyond its luminous band lay strange silent forms that refused to fit inside the model of a finite cosmos. For centuries, humanity clung to its island, unwilling to let go of the illusion of enclosure. Yet every new discovery was a wave breaking against that fragile shore, a reminder that infinity does not need our permission to exist. To the astronomers of the past, the sky was not a void, but a grand machine. Stars were thought to be fixed to a celestial sphere, each point of light a jewel embedded in a perfect dome. The faint mist of the Milky Way seemed like a glowing vapour, perhaps the residue of creation itself. And those strange nebulae, the spirals, the ellipses, the soft clouds, were often imagined as storms in the ether, whirlpools in some invisible fluid filling space. It was a universe that felt alive, mechanical yet divine. Space was not emptiness, but a medium carrying the breath of the heavens. Gravity, light and motion were threads in a single cosmic fabric woven by unseen hands. Even when new discoveries began to challenge this view, many resisted. The idea that the universe might stretch endlessly into the dark felt cold and impersonal. People preferred the familiar warmth of a cosmos designed around them, a stage where humanity still held meaning beneath the stars. The transformation began with a single kind of star, the Cepheid variable. These remarkable suns pulse with predictable rhythm, their brightness rising and fading like a heartbeat. In the early 20th century, astronomer Henrietta Swan Leavitt discovered that the speed of their pulse was tied to their true luminosity. The brighter the star, the slower it beat. This simple relationship would become one of the most powerful tools in astronomy, a way to measure distance across unimaginable scales. For the first time, light could be turned into a ruler. By comparing how bright a Cepheid appeared from Earth to how bright it truly was, astronomers could calculate its distance with astonishing accuracy. Suddenly, the fog of space began to thin. Nebulae that had once seemed close were revealed to lie far beyond the Milky Way. The universe, once intimate and enclosed, was opening like a vast map, and at its centre humanity stood smaller than ever, staring outward with newfound humility. Even as astronomers learned to measure distance, few could grasp what those numbers implied. If the spiral nebulae truly lay beyond the Milky Way, then the universe was incomprehensibly vast and perhaps alive with motion. Yet motion itself was forbidden by the prevailing view of the cosmos, a static eternal structure balanced perfectly between gravity and silence. To imagine it expanding was to imagine the universe itself changing, something many found impossible, even heretical. The evidence, however, was quietly building. Spectra from distant galaxies showed subtle shifts toward red, as if their light was stretched by some invisible hand. But in the early years of the 20th century, few understood what that meant. The data was strange, the implications stranger. Astronomers gathered results without knowing they were witnessing the first signs of a moving universe. It would take one man and one mountain observatory to turn this invisible drift into a cosmic revelation. In the years just before Edwin Hubble's discovery, astronomy felt poised between wonder and doubt. The sky had been mapped, the stars measured, and yet something fundamental was missing. Every observation hinted at motion, but no one could explain what was moving or why. The universe still seemed timeless, fixed, almost comfortable in its stillness. It was an age of quiet triumph built on the illusion that humanity had nearly solved the sky. Then came the silence before the storm. Across the world's observatories, faint spectra were being recorded, each one carrying a redshift no one could fully interpret. The answers were already written in the light, waiting only for the right mind to read them. Hubble's telescope stood ready on Mount Wilson, aimed not at mystery, but at confirmation that the universe was far larger and far less stable than anyone dared to believe. The calm was about to end. High above the clouds of California on the slopes of Mount Wilson, a new eye opened to the cosmos. The Hooker telescope, 100 inches of flawless glass, was the largest ever built. When Edwin Hubble first climbed its narrow steel stairs in the early 1920s, he wasn't seeking fame, he was seeking clarity. Every night he looked deeper into those mysterious spiral nebulae, hoping to find a sign that could tell him how far away they truly were. I often imagine that moment, the mountain air, the hum of machinery, the faint tremor of starlight falling onto the mirror. It must have felt like standing at the edge of discovery, staring into a depth no one had measured before. The great dome turned, slowly following the sky, while Hubble's glass eye captured the whispers of distant suns. From that quiet summit, the cosmos was about to reveal its true dimension, and in doing so, it would forever change how humanity saw itself. On a cold night in 1924, Hubble captured something that would end centuries of illusion. In the spiral of Andromeda, he identified a Cepheid variable, a single flickering star hidden among millions. Using Henrietta Leavitt's formula, he calculated its distance and found it lay far beyond the boundaries of the Milky Way. That one tiny pulse of starlight carried a truth large enough to redefine existence. Our galaxy was not the universe, only one of countless others adrift in the dark. I still find that thought staggering. It's hard to imagine how it must have felt, the quiet realization that every patch of sky was alive with galaxies, each one filled with stars and worlds of its own. For the first time, humanity understood the scale of creation not through myth or faith, but through measurement. A single observation had broken the walls of the cosmos. The night sky would never feel small again. The phrase beyond the Milky Way seems simple now, but in Hubble's time it was revolutionary. To be beyond meant to exist outside everything humanity had ever known. For thousands of years, the Milky Way had been the whole of creation, a glowing river of stars surrounding our tiny world. Hubble's measurement transformed that river into just one of many. Space was no longer a stage with a single backdrop, but an ocean filled with islands of light stretching far past imagination. It was more than a discovery. It was a displacement. Suddenly, humanity was no longer at the center of anything. The cosmos had expanded, and with it our sense of belonging dissolved into scale. Yet that loss of centrality brought something profound. Perspective. The farther we drifted from the center, the more beautiful the picture became. Hubble hadn't just expanded the map of space, he had expanded the boundaries of wonder itself. In the wake of Hubble's discovery, astronomy itself had to be rebuilt. What was once a study of a single galaxy suddenly became the science of galaxies plural. Every nebula that had puzzled observers for centuries was now reclassified as a distant world, each containing billions of stars. The universe had multiplied overnight. It was as if the cosmos had been quietly waiting for someone to notice how vast it truly was. Humanity had taken its first step into the realm of the extragalactic. That moment reshaped everything. New questions replaced old certainties. How did these galaxies form? How many were there? Were they moving, and if so, why? A new generation of scientists began to map the sky again, not to chart stars, but to trace the architecture of creation itself. I imagine the feeling of standing under that redefined sky, realizing that every faint smudge of light was a separate island of suns. The night had never been so crowded or so alive. Before Hubble distance was measured in familiar terms, thousands of light-years, numbers large but still conceivable, the Milky Way fit neatly within those boundaries, a grand but comprehensible island of stars. But when Hubble measured Andromeda, that comfort vanished. 2.5 million light-years, a number so large it broke the language of comparison. The scale of the cosmos had shifted overnight, leaving even the most rational minds struggling to imagine what those figures meant. To think of millions of light-years is to confront time itself. Every beam that reaches us began its journey before humanity existed, crossing eras older than Earth's mountains or oceans. The universe had always been vast, only now did we finally know how vast. I like to think Hubble understood that quiet weight, the realization that every new measurement didn't just expand space, it expanded humility. Numbers had become a form of poetry written across the darkness. When Hubble's results were first announced, the reaction was disbelief. Newspapers spoke of island universes, and for the first time the phrase wasn't poetic, it was literal. Ordinary people read that our Milky Way was not the whole of creation, but just one among countless others. The idea was exhilarating and terrifying at once. It stripped away the comforting sense of being central and replaced it with something vaster, colder, and infinitely more beautiful. I imagine the quiet awe of those who stepped outside that night staring at the same sky with new eyes. Every familiar star suddenly belonged to a greater architecture, one galaxy among billions. The boundary between myth and science had blurred again, but this time in the opposite direction. Knowledge had become the new wonder. For the first time in history, humanity understood its smallness, and in that smallness found something close to meaning. Hubble's second revelation was even greater than the first. By comparing the redshifts of galaxies to their distances, he found a pattern. The farther away a galaxy was, the faster it seemed to recede. The relation was simple, elegant, and devastating. Space itself was stretching. The galaxies were not flying through the void was expanding between them. For the first time, the cosmos was not static but dynamic, a living fabric in motion unfolding in every direction. I remember the first time I learned about that law. It felt like a horizon moving inside my mind. Every number on Hubble's chart carried a quiet astonishment, proof that the universe was neither eternal nor still. It was growing, changing, and aging like everything else. The discovery rewrote the story of creation itself. In that expanding sky, humanity saw both its insignificance and its belonging part of a motion that had no center, no edge, and perhaps no end. After Hubble's discovery, the universe took on structure. No longer was it a random scattering of stars, but an intricate design built from galaxies, vast collections of suns bound by gravity, each spinning in silent harmony. They became the new atoms of the cosmos, the basic units of a far greater architecture. From spirals to ellipticals, dwarfs to giants, every type told a story of formation, collision, and change. The Milky Way was no longer unique. It was a single brick in an endless cosmic wall. When I think of that, I feel both smaller and more connected. Every galaxy, no matter how distant, is a reflection of our own, born from the same physics, sculpted by the same laws. The realization that billions of these systems fill the observable sky gives our existence a strange kind of intimacy. We are not separate from the structure of the cosmos. We are part of its pattern. The galaxies are its handwriting, and in their shapes the universe records its history. The discoveries of Hubble changed more than astronomy. They changed how humanity saw itself. For centuries we had measured greatness by proximity. The closer to the center, the more important. But now the center was gone. Every point in the cosmos could be the middle, and none of them truly were. In that realization, something profound emerged. A perspective that stripped away pride and replaced it with wonder. The universe wasn't made for us. We were made from it. I often think about that shift and how quietly it must have arrived. No fireworks, no divine revelation, just data lines on a graph light caught by glass. Yet from those details came a vision vast enough to reshape philosophy, religion, and art. The cosmic perspective isn't about feeling small, it's about recognizing connection. The same laws that sculpt galaxies govern the cells in our bodies. To understand the cosmos is to understand ourselves not as exceptions but as expressions of it. In the years that followed Hubble's discovery, astronomers faced a new challenge to chart what had no edges. The sky was no longer a flat dome of stars but a three-dimensional expanse filled with islands of galaxies. Observatories around the world began to gather redshifts, measuring how far each system drifted into the distance. The first maps looked primitive, fragile lines drawn across infinity, yet behind them lay a new truth. Space itself had a shape, and humanity was learning to trace it. I like to imagine those early maps pinned to the walls of smoky observatories, the dots of ink glowing under lamplight. Each one marked a place that no human would ever visit, and yet we knew it was there. Bit by bit, the cosmos turned from abstraction into architecture. Galaxies became coordinates, light became geography. For the first time, we weren't just looking at the night sky, we were beginning to understand where we were inside it. The first redshift maps were more than records, they were revelations. As astronomers plotted thousands of galaxies by their distance and direction patterns began to appear, the cosmos was not random. Galaxies clustered into chains and sheets, leaving vast empty spaces in between. These were the first hints of a hidden architecture, a structure too large for the human mind to grasp. The universe was not a uniform mist of stars, but living network stretching across unimaginable scales. Detectors buried deep underground listen for particles that never seem to appear. Space telescopes watch for subtle distortions in light, hoping to catch the faintest sign of the invisible. So far, no one has touched dark matter directly, but its influence is everywhere, written into every spiral arm and cluster orbit. It's as if the universe left us clues in gravity, daring us to understand what holds it all in place. Just when astronomers thought they understood gravity's hold on the cosmos, the universe delivered another surprise. In the late 1990s, distant supernovae revealed something impossible. The expansion of space was not slowing down, but accelerating. Some unseen force was pushing galaxies apart faster and faster. They called it dark energy, a name that explained nothing, only acknowledged the unknown. Whatever it is, it dominates everything, making up nearly 70% of the cosmos. To me, that discovery feels like the universe taking a deep breath, expanding, not collapsing. Dark matter pulls, dark energy pushes, and between them lies the fragile balance that defines cosmic history. We don't yet know what dark energy is, vacuum pressure, quantum field, or something entirely new, but its influence is unmistakable. Every moment, the space between galaxies grows wider, and somewhere in that silent expansion, our story continues to unfold. If space is expanding, how fast is it doing so? That question defines modern cosmology. The answer is encoded in a single number, the Hubble constant. It measures how quickly galaxies move away from one another as the universe grows. To calculate it, astronomers compare redshift with distance, watching how the stretching of space changes with scale. It sounds simple, yet it's one of the most difficult measurements ever attempted. Even today, no two methods agree completely. I've always found that tension fascinating, how precision itself can reveal mystery. Measurements from the early universe using the cosmic microwave background give one value. Observations of nearby galaxies using Cepheids and supernovae give another. The disagreement, small yet persistent, hints that we may be missing something fundamental. Perhaps dark energy changes with time. Perhaps the fabric of space isn't as uniform as we thought. Whatever the cause, the universe still refuses to be pinned down by a single number. The Hubble constant isn't just a number, it's the speed of creation unfolding. It means that every megaparsec of space, every stretch of the cosmic fabric expands by a set amount each second. Galaxies aren't flying through space like debris from an explosion. The space between them is stretching. That's why there is no true center to expansion. Every point moves away from every other. The universe doesn't grow into something, it grows within itself. When I first grasped that, it changed the way I looked at the night sky. The stars overhead are part of a motion too slow for human senses, yet relentless across eternity. Even the Milky Way, our cosmic home, is adrift on this tide of expansion. The numbers, cold and mathematical, hide a quiet poetry. We are all passengers on the same stretching sea of space-time. Every moment the distances grow, and so does the story of everything that ever was. Every expansion invites a question. How does it end? For decades, astronomers imagined three possible destinies. If gravity was strong enough, the cosmos might one day collapse, the big crunch, a fiery rebirth where everything returns to a single point. If expansion balanced gravity perfectly, the universe would slow forever, frozen at the edge of stillness. But if expansion kept accelerating, driven by dark energy, it would end not in fire but in silence, a heat death where even starlight fades away. It's a strange kind of destiny measured not in years but in trillions. Galaxies drifting beyond visibility, stars burning out matter itself, decaying into whispers of energy. Yet in that distant future, the story isn't tragedy, it's transformation. The same forces that tore the early universe apart will one day stretch it beyond our sight and perhaps beyond meaning. When I think about that, it feels less like an ending and more like the cosmos taking a long, slow breath, one that never quite exhales. The fate of the universe is written in a single word: entropy. It's the measure of disorder, the quiet law that ensures energy spreads, structures crumble, and warmth fades into cold equilibrium. Every star that burns, every planet that cools, every atom that moves contributes to this slow drift towards stillness. The cosmos began in a blaze of low entropy, concentrated, ordered, alive with potential. But over time, that order unravels. The universe is trading brilliance for balance. In every heartbeat of the sun lies the same principle that shaped Galaxies' energy escaping gravity's grip, becoming light. Life is possible only on the edge of destruction. Too little energy and matter freezes into stillness. Too much and it burns before it can organize. Stars sit precisely on that knife's edge, massive enough to ignite but not so massive that they tear themselves apart. Around them, planets orbit in delicate harmony, each one tracing a path between fire and frost. Within that narrow band, chemistry wakes up and calls itself alive. I find that balance astonishing. The same nuclear fire that lights our days also hides the power to erase us. Energy and chaos are not opposites. They are twins bound by the same laws. Entropy pushes toward disorder. Yet from that push comes the gradient that fuels every flame, every cell, every heartbeat. The universe survives not by avoiding chaos, but by dancing with it perfectly, perilously, and beautifully. Long before life breathed or moved, chemistry began to dream. In the young oceans of ancient worlds, energy from sunlight, lightning, and volcanic heat stirred simple molecules into something new, chains that could copy themselves. From randomness emerged replication, and from replication evolution. Carbon became the storyteller of the cosmos, weaving atoms into patterns that could change, compete, and remember. It was the moment when matter first learned to persist. I like to think of it as the universe experimenting with memory. Each molecule was a tiny archive of success, keeping what worked and discarding what didn't. Over billions of years, chemistry became biology order, born from chaos, complexity rising from simple rules. Life is not an accident. It's the cosmos organizing itself against the pull of entropy. Every cell is a rebellion, every genome a record of the universe learning how to hold on. From the first spark of chemistry to the rise of thought, evolution is the universe learning to know itself. Atoms forged in stars became molecules, then cells, then minds capable of looking back at the stars that made them. The energy that once burned in stellar cores now flickers in neurons passing as electricity through living tissue. Consciousness in that sense is not separate from the cosmos, it's its echo folded inward. I find that idea quietly humbling. It means that every thought, every dream, every act of wonder is starlight reorganized, the universe experiencing itself through us. Evolution is not progress, but persistence. A long experiment in balance between chaos and order. From galaxies forming in the void to minds forming in skulls, the same principles apply. We are the brief moment when matter becomes aware of its own impermanence and chooses to marvel anyway. In a universe of trillions of galaxies, the odds seem generous. Somewhere beyond the veil of light there should be other minds, other worlds that ask the same questions we do. Yet so far the cosmos has remained silent. The same laws that allowed consciousness to arise also make it fragile. It requires stability, energy, and time, three gifts that rarely align. Perhaps life is common, but awareness, that spark of reflection, is rare beyond measure. I sometimes wonder if consciousness is the universe's brief way of watching itself before it fades. For all our technology and telescopes, the only confirmed intelligence we know is our own, a single flame in a sea of darkness. And still that flame matters. It means the cosmos has at least once become self-aware, even if no other voices ever answer the fact that we can ask the question, may be enough proof that existence itself was listening. For more than half a century we've been listening. Radio telescopes sweep the sky, sifting through cosmic static for a signal that might prove we're not alone. We've sent messages, probes, even the sounds of our planet into the dark, hoping that somewhere another civilization has done the same. Yet the universe answers only with silence. It's not an empty silence, but one filled with the hum of stars, the echo of creation, and the quiet reminder that distance itself can be more absolute than any wall. Sometimes I think that silence is part of the message. Perhaps intelligence is too fleeting to overlap, or communication too slow to bridge the light years between us. Or maybe the cosmos is filled with life that has simply learned to listen, not to shout. The search continues, and maybe that's the point, that curiosity itself is the sign of consciousness. Even without an answer, we are proof that the universe still wonders. The silence of the universe is not empty, it's paradoxical. With trillions of galaxies and countless stars, probability alone suggests life should be everywhere. Yet the more we look, the lonelier it seems. Some scientists think civilizations may rise and fall too quickly, burning through their resources before they ever reach the stars. Others suggest that intelligent life aware of its own fragility chooses not to broadcast learning, that survival often means staying quiet. When I think about that, it feels hauntingly human. Maybe the universe isn't silent because it's empty, but because it's cautious. Perhaps every civilization reaches a point where curiosity meets fear, the realization that listening is safer than speaking. And so across the cosmic dark, countless minds might be waiting, each wondering if they are alone. The great silence then is not proof of absence, but of distance, patience, and the fragile hope that someone somewhere is still listening. In a galaxy of hundreds of billions of stars, our world should be ordinary. Yet the more we learn, the more unlikely it seems. Earth formed in a narrow band where liquid water could exist close enough to the sun to stay warm but far enough to avoid burning. Its orbit is nearly circular, its tilt stable, its moon unusually large. Even its magnetic field, born from a molten core, acts as a shield against the solar wind. Each condition alone is common. Together they are miraculous. Sometimes I wonder if luck is just another law we haven't named yet. Everything we depend on, air, oceans, carbon, DNA, came from a chain of coincidences that almost didn't happen. In the grand equation of probability, Earth is an exception written in fragile ink. And yet here it is, glowing blue in the cosmic dark, alive against the odds. The universe may be vast beyond comprehension, but for now this tiny world remains its only confirmed miracle. The story of life is also the story of balance. While planets elsewhere froze, boiled, or drifted into chaos, Earth remained steady. Its orbit hasn't wavered wildly. Its climate, though fragile, has stayed within a narrow band where life can adapt. Plate tectonics recycle carbon oceans, buffer heat, and the atmosphere thin as a whisper shields against radiation. Even disasters from asteroid strikes to ice ages became catalysts for renewal. Stability, it seems, is not the absence of change, but the rhythm of survival. When I look at our world through that lens, it feels deliberate, though I know it isn't. Chance alone could have tipped the scales 1,000 times, yet Earth persisted. For 4.5 billion years, this planet has walked a tightrope between order and collapse. And somehow, through all of it, life never stopped trying. The cosmos offers no guarantees, only the rare coincidence that for now everything still works. After all our searching, all our wondering, we return home to a single galaxy, adrift in an ocean of light. The Milky Way is our island in the cosmic sea, a vast spiral of stars turning in quiet majesty. 100 billion suns trace its arms woven through with clouds of dust and hydrogen. From edge to edge, it spans more than 100,000 light years, yet every glimmer, every world is bound together by gravity's invisible grace. Sometimes I imagine looking at it from afar, a soft whirl of gold and blue, serene and self-contained, unaware of the minds within it trying to understand. Our entire history, every word and dream is written on one faint spark among its billions, and beyond it lie trillions more each, a potential cradle of life, each a mystery waiting for light to reach us. In knowing our galaxy, we begin to glimpse our place among the rest. The Milky Way isn't a flat band of light across the night sky, it's a grand rotating structure. At its heart lies a dense bulge of old stars orbiting a supermassive black hole named Sagittarius A star, 4 million times the mass of our Sun. Around this glowing centre stretches a vast thin disk, home to the spiral arms where new stars are born. Beyond the disk lies the halo, a ghostly sphere of ancient stars and dark matter tracing the galaxy's invisible skeleton. I sometimes picture it like a city seen from above a bright core surrounded by sprawling suburbs glowing in quiet motion. Each spiral arm is a neighbourhood of creation filled with stellar nurseries and clouds where future suns wait to ignite. The Milky Way is both ancient and alive, its stars moving in silent orbits that will continue long after ours are gone. In studying its shape, we study the blueprint of galaxies themselves. At the heart of the Milky Way lies a region unlike anywhere else, the galactic centre, a realm where gravity bends both light and time. Here, stars orbit at breakneck speeds around a single invisible anchor, Sagittarius A star, a black hole more than 4 million times the mass of the Sun. Infrared telescopes have watched these stars complete their orbits, their motion revealing the immense hidden mass that keeps the galaxy bound together. It is a silent engine, compact, voracious and ancient. I often think of it as the galaxy's pulse beating slowly beneath the noise of creation. Around it, dense clouds collapse into new stars while others are shredded by its pull, their light twisted into arcs by space-time itself. The centre of the Milky Way is both cradle and grave, a place where destruction and creation merge into one. It reminds me that gravity is not just a force, it's the rhythm of existence, the quiet law that shapes everything we see. From the galactic centre, vast arms unfurl luminous rivers of stars winding through the dark. These are the spiral arms of the Milky Way, where gravity and rotation sculpt the flow of matter into graceful waves. The arms aren't solid structures, but patterns of density moving like ripples through the disk. Within them, gas clouds compress, ignite, and give birth to new suns, while older stars drift outward, leaving trails of light across the galactic sea. I often think of them as the veins of a living organism carrying energy, motion, and renewal through the body of our galaxy. The Orion Arm, where our Sun resides, is just a minor branch, yet it holds the story of every human life ever lived. When we look up and see the Milky Way stretch across the night, we're seeing our position. Within one of these currents, a single eddy in a spiral that has been turning for billions of years. The Sun is not still, it is a traveller. Every 230 million years it completes one orbit around the galactic centre, carrying Earth and the other planets with it. That means since its birth, the Sun has circled the Milky Way more than 20 times. Our solar system moves at nearly 800,000 kilometers per hour, yet we never feel it. The sky seems still because everything around us shares the same great voyage, turning together through the galaxy's immense spiral. Sometimes I imagine what the sky looked like on our last trip around dinosaurs, watching a completely different set of constellations, the arms of the Milky Way arranged in another configuration. Every revolution is a cosmic year longer than all of human history. We live our lives inside a motion too vast to sense, yet it defines where we've been and where we're going. The Sun is not just a star, it's a pilgrim in a galaxy that never stops moving. Our solar system drifts through a quiet suburb of the Milky Way. Within 10 light years, only a handful of stars keep us company. Proxima Centauri, Alpha Centauri, Barnard's Star Wolf 359. In cosmic terms, they are neighbours, yet the distances between them are enormous. If the Sun were the size of a coin, the nearest star would still be thousands of kilometres away. Space between stars is not empty, but thin, filled with a faint breath of hydrogen, magnetic fields, and ancient starlight. I sometimes think of this region as the calm between storms. Far from the violent heart of the galaxy, we orbit in safety, cocooned in relative silence. Our sun is an average star in an average place, yet from this quiet corner, life arose and looked outward. Perhaps that's what makes this neighborhood special. Not its brightness or size, but its peace. In the stillness between suns, consciousness had time to grow. Not every place in a galaxy can host life. Near the center, stars are packed too tightly, their radiation fierce and unpredictable. Far out in the halo, there isn't enough heavy matter. No carbon, oxygen, or iron to build worlds. Between these extremes lies a narrow ring called the galactic habitable zone. Here star density is gentle, supernovae are rare, and the elements for life are abundant. Our sun sits perfectly within that ring in one of the safest neighborhoods the Milky Way has to offer. When I learned that, it felt like discovering a hidden design. Not of intent, but of consequence, a balance born from billions of chaotic events. Earth exists not just because of where it formed, but because of where the galaxy allowed it to. Every rotation around the Milky Way keeps us inside this fragile corridor of habitability. It's a reminder that survival isn't random. It's the universe's way of giving order a fighting chance. Galaxies are not static islands, they are dancers in a cosmic ballet. Over billions of years, gravity draws them together, merging their stars, gas and dark matter into new forms. What seems like collision is in truth choreography on a scale beyond imagination. When two galaxies meet, most stars never touch. Instead, they pass through one another, their paths bent by invisible tides. In their wake, vast streams of starlight stretch like ribbons, glowing remnants of a gravitational embrace. I find it haunting that destruction and creation look so alike. These encounters ignite new waves of starbirth, while supermassive black holes at their centers merge into even larger ones, sending ripples of gravity across the fabric of space. One day our own Milky Way will meet Andromeda in this slow-motion dance, two spirals becoming one. It will take billions of years, but the outcome is certain. Even galaxies, it seems, cannot resist the pull of reunion. Across the cosmic gulf, another spiral approaches. Andromeda, the nearest large galaxy to ours, is racing toward the Milky Way at over 400 kilometers per second. In about 4 billion years, the two will collide, not in an explosion, but in a slow, graceful merger that lasts another few billion. Their shapes will distort spiral arms, stretching and twisting stars flung into vast arcs of light. From afar, it will look like two galaxies embracing and becoming something new. I like to imagine what the night sky will look like then. Andromeda will grow larger each million years until it fills the heavens a glowing storm of stars. Earth, if it still exists, will drift through tidal fields of light and darkness untouched but transformed by the view. When the merger ends, a single elliptical galaxy will remain Milkdromeda, a monument to cosmic inevitability. Even in a universe that expands forever, gravity still finds a way to bring things together. When the collision ends, chaos gives way to calm. The Milky Way and Andromeda, once separate spirals, will settle into a single massive elliptical galaxy. Brighter, rounder, quieter. Billions of stars will have shifted into new orbits, while clouds of gas ignite one final wave of starbirth before exhaustion sets in. Astronomers already call this future system Milkdromeda, a monument to gravity's patience and time's persistence. From within it, the sky will glow with countless suns, no longer a flat band, but a vast golden sphere of light. I find that image oddly comforting. Long after Earth is gone, the atoms that once made oceans, trees and mines will still be here circling in this new creation. The merger isn't an ending, it's renewal on a galactic scale. Two ancient spirals becoming one, their stories blending into a single orbit of light. Even as the universe drifts towards silence, it continues to build, to merge, to begin again. The Milky Way and Andromeda are not alone. They belong to a small family called the Local Group, a cluster of more than 50 galaxies bound together by gravity. Around the giants drift smaller companions, the Magellanic Clouds Triangulum and countless dwarfs faint and ancient. Over time, all of them will fall inward, merging into the growing mass of Milkdromeda. One by one, their orbits will decay their stars, joining the slow swirl of a single colossal system. It's strange to think that billions of years from now, the local group will become just one galaxy, drifting alone through an expanding void. The rest of the universe will have receded beyond visibility. The cosmic web stretched so far that no new light can reach us. Future astronomers, if any remain, will see only their own galaxy and nothing beyond it. The night sky will be smaller, quieter, and lonelier. Yet even then, the story of everything will still be written in its start. The future belongs to emptiness. As dark energy drives the expansion ever faster, galaxies outside our local group will slip beyond the cosmic horizon, their light stretched until it fades from view. 100 billion years from now, the night sky will be empty, no Andromeda, no clusters, no trace of the universe we once knew. The stars will die one by one, leaving behind white dwarfs, black holes, and drifting embers of matter. The cosmos will not end in fire, but in distance. I sometimes think of that as the ultimate quiet, not destruction, but erasure. Each particle will grow lonelier, each photon weaker, until even time itself seems to lose direction. And yet in that far future, the remnants of our galaxy will still orbit in darkness, holding the last whispers of creation. The universe began with light, and it will end with memory, a vast frozen echo of everything that ever was. Long after galaxies fade and stars go out, a few sparks will remain. White dwarfs will cool into black embers, radiating the last traces of warmth into the expanding dark. Neutron stars will spin slower and slower until even their pulses fall silent. For a time, the only light in the universe will come from matter collapsing into black holes, a brief final blaze as they evaporate through Hawking radiation. And then even that will stop. The universe will go dark utterly and forever. It's a strange kind of peace, a stillness so complete it becomes beautiful. No motion, no heat, no stars, just a quiet sea of particles too cold to glow. Yet in that silence lies everything that ever was. Every atom, every photon, every memory of light still drifts through the void, stretched thin but unbroken. The end of time will not be a scream but a whisper, the universe fading into the gentlest possible nothing. Even in darkness, nothing is truly lost. According to the laws of physics, information cannot vanish, not even inside a black hole. Every particle, every photon, every vibration of energy that ever existed leaves a trace encoded in the structure of space-time itself. The universe keeps its own memory scattered across the fabric of reality like a cosmic archive too vast to read. Light that left a star billions of years ago still travels stretched and faded, yet never gone. I find that thought deeply comforting. It means that the universe remembers everything. The birth of galaxies, the flicker of stars, even the brief glow of human life. Long after we're gone, the echoes of our existence will still drift through space, faint but real. Perhaps that is the true immortality of matter, not to last forever, but to leave an imprint that never fades. The cosmos forgets nothing. It only grows quieter in how it remembers. We know how the universe began. We can describe how it will end. But why it exists at all, that remains the most elusive question. Physics can explain the birth of energy, matter, and time, yet not the reason behind their presence. Some theories suggest our universe could be one of countless others, each with different laws of nature. Others argue that existence needs no reason, that nothing itself was unstable, and reality was the inevitable result. Still, the question lingers, why does anything exist instead of nothing? When I think about that, I find meaning not in the answer but in the asking. Perhaps the universe exists simply so that it can be known, so that something somewhere can look up and wonder. Consciousness may not be an accident, but the way the cosmos becomes aware of itself. From the first spark of light to the thoughts forming right now, Everything we understand is the universe learning to remember its own name. Every atom in your body was forged in the heart of a star. The carbon in your cells, the iron in your blood, the calcium in your bones, all were created in stellar furnaces that lived, burned, and died long before the sun was born. Supernovae scattered these elements through space, seeding the clouds that would one day collapse to form new stars, new worlds, and life itself. You are quite literally made of the universe's memory, the dust of dead stars rearranged into awareness. Sometimes I think that's the most beautiful truth we've ever found. When you breathe, when you think, when you look at the sky, the cosmos is observing itself through you. The boundary between us and it dissolves. We are not in the universe. We are the universe in a brief and conscious form. For a fleeting moment in eternity, matter has opened its eyes, and it's looking back toward the light that made it possible. Somewhere along the universe's vast timeline, atoms began to dream. After billions of years of stars living and dying, their ashes formed worlds where chemistry became biology, and biology became thought. Neurons sparked, patterns formed, and from those patterns arose awareness, the ability of matter to know itself. Consciousness is not an external gift. It's the universe awakening within itself, one mind at a time. Every thought we have is built from the same particles that once burned inside suns. It's hard to grasp how extraordinary that is. The cosmos that seemed silent now speaks through voices made of stardust. We often think of ourselves as small, yet we're the only known way the universe can observe its own beauty. When matter learned to think, the universe crossed a threshold from existence to understanding. And maybe that's the real miracle. Not that we are here, but that we know we are. Consciousness feels inevitable to us, but it may be the rarest phenomenon in the universe. It depends on a delicate chain of events, the right planet, the right chemistry, the right stability across billions of years. A single cosmic accident could have erased that possibility at any point. Life itself is fragile, awareness even more so. Out of countless stars and worlds, only one is known to have produced minds that can question their own existence. For now, thought seems to be the universe's most fleeting experiment. Sometimes I wonder how many times that experiment has failed. How many civilizations might have risen, looked into their own sky, and vanished before their signal ever crossed the stars. Awareness could be like lightning, bright, brief, and gone. Yet in that briefness lies its beauty. The universe may not favour consciousness, but it allows it, and that allowance alone feels miraculous enough. If life is common but intelligence is rare, something must be stopping it. This is the idea of the great filter, an unseen threshold that few, if any, civilizations survive. Maybe most never reach intelligence at all, or perhaps they do only to destroy themselves before they can spread beyond their world. The filter could be war resource, collapse, artificial intelligence, or something deeper, a natural limit written into the physics of survival. Whatever it is, it has kept the stars silent. I find the idea both terrifying and humbling. If the great filter lies ahead of us, our future may be short, but if it lies behind us, then we're among the few who made it through, the lucky survivors of cosmic odds. Either way, the silence of the sky becomes meaningful. It is not proof of emptiness, but of difficulty. Intelligence may be the universe's most fragile achievement, a flame that burns brightly, but never for long. If some civilizations have survived the great filter, they would be ancient beyond imagining. To endure, they must have learned to master their environment, to harness energy without destroying their world, and to adapt faster than extinction itself. Such beings might no longer rely on biology. Their minds transferred into machines or fields of information spread across space. They could live within stars or around them, drawing power from light for as long as it burns. Their existence would not be loud but quiet, the silence of perfect control. I often wonder what they would think of us. Would they see us as children just beginning to understand what survival truly means, or as a reflection of themselves long ago before they learned restraint? Maybe the greatest achievement isn't conquering the universe, but learning how to stay in harmony with it. To outlive the filter is to stop fighting nature and start becoming part of its rhythm. If any civilization has truly mastered survival, they would not just endure, they would build with light itself. Physicist Freeman Dyson once imagined structures vast enough to surround entire stars, capturing every ray of energy they emit. A Dyson sphere would make its builders nearly invisible, hidden behind the glow they harvest. Others have proposed even grander ideas: networks of stars connected by energy bridges or galaxies reshaped to channel light more efficiently. To us, these would appear as silent anomalies, dark objects where brightness should be order, where chaos once ruled. Sometimes I wonder if we've already seen them. Perhaps the faint infrared glow of distant systems isn't random, but the waste heat of something far beyond our understanding. The universe could already be full of such architects, not conquerors but caretakers of starlight. In a cosmos driven by entropy, they would stand as its rarest creation. Minds that learned not just to survive the dark, but to build beauty from it. To shape a star is to rewrite the laws of nature. A civilization capable of that would operate on scales beyond comprehension, adjusting stellar lifetimes, reigniting fading suns, or fusing entire gas giants into new light. They might rearrange constellations, stabilizing orbits to prevent collisions, or harvest matter from dying stars to seed new ones. These acts wouldn't be done for conquest, but for balance guiding the galaxy, as a gardener tends a forest, ensuring that energy never goes to waste. It's almost poetic to imagine such beings architects who sculpt with gravity and time. Their tools would be black holes and magnetic fields, their canvas the very fabric of space-time. Perhaps they no longer build cities or planets, but symphonies of light orchestrating stellar evolution across eons. And if they exist, their handiwork might already fill the night sky patterns of order so vast that we mistake them for the randomness of nature itself. When the last stars fade, survival will demand a new kind of power, no longer drawn from fusion or starlight, but from the deep fabric of reality itself. Advanced civilizations might learn to extract energy from the quantum vacuum, the endless sea of virtual particles flickering in and out of existence. Others could tap the spin of black holes using their immense gravity as turbines that feed on spacetime's rotation. These ideas sound impossible, but they are written into the physics we already know. I like to imagine such beings living in the twilight of time, harvesting the whispers of creation itself. They would not measure existence by centuries or suns, but by the slow heartbeat of the cosmos. Each quantum of energy, each particle reclaimed would become sacred. In that age of fading light, survival would no longer be about domination, but endurance, the art of making meaning last even when the universe itself forgets. In the far future, when the galaxies are gone and the stars have burned to ash, the universe may still have builders. They would work in silence, not with matter or metal, but with fields and quantum patterns, constructing networks of information that can survive without energy. Perhaps they would weave themselves into the structure of space-time, encoding memory directly into the fabric of reality. Their creations wouldn't shine, but endure invisible monuments to persistence in a universe that no longer remembers its own light. I sometimes picture them as the final artists of existence. While entropy erases everything else, they would sculpt meaning from decay, designing systems that can last beyond time's reach. Maybe they wouldn't call it survival anymore, just continuity. A quiet promise that knowledge will not fade. When all motion stops, they would remain as whispers in the void, reminding whatever comes next that once the cosmos built things simply because it could. Every civilization, no matter how advanced, eventually faces the same question. How do you leave a trace in a universe that erases everything? Stars collapse, galaxies dissolve, even atoms decay, yet information in its purest form can outlast them all. Some dream of sending signals beyond the horizon, others of encoding thought into black holes or into the quantum noise between dimensions. Perhaps the greatest legacy isn't a monument that endures, but a pattern that repeats a structure so universal that it reappears whenever conditions allow. I like to think that meaning itself is the universe's signature, Every time life emerges, every time awareness stirs, the same cosmic melody plays again, a song written in physics, memory, and light. Maybe eternity doesn't need witnesses. Maybe existence remembers itself simply by becoming aware again and again. If so, then we've already left our mark not in stone or metal, but in the endless echo of consciousness returning to wonder. What if the end is never truly the end? Some theories suggest that our universe may not die but recycle, collapsing under its own gravity, only to ignite again in a new burst of creation. A big crunch followed by a new big bang. Others imagine a big bounce where expansion slows, reverses, and begins anew, a cosmic heartbeat pulsing through eternity. Each cycle would erase the traces of the last yet preserve its laws, its constants, and perhaps even its echoes. I find that idea strangely comforting, the thought that nothing is ever truly gone. Maybe every universe leaves behind a blueprint for the next, just as dying stars seed new worlds. Matter becomes energy, energy becomes motion, and motion becomes life again. The circle closes only to open once more. If creation is infinite, then every moment, even this one, is both an ending and a beginning. The cosmos may not seek purpose, but it never stops becoming. If the universe truly begins again, what happens to everything that came before? Most models say it all disappears, galaxies, atoms, even time itself. But some theories suggest traces remain, faint imprints carried through the collapse and rebirth. Patterns in the cosmic background, quantum scars woven into the vacuum echoes from a universe that no longer exists. Like a dream half remembered upon waking reality might begin each cycle not from nothing but from memory blurred by infinity. That thought feels both haunting and beautiful. If existence repeats, then we are not the first version of ourselves nor the last. Every thought, every light might return in some form again and again, endlessly reassembled. The universe forgets the details but keeps the rhythm, a grand recurrence where meaning flickers, fades, and finds its way back. Maybe eternity isn't about lasting forever, but about returning until the song of creation is perfect. Some physicists believe that our universe may not be alone but mirrored. A reflection on the other side of the Big Bang where time flows backward and matter becomes antimatter. In that realm, entropy decreases instead of rising, and every event in our universe has its inverse twin. Together they balance reality like two halves of a cosmic equation. We would never meet these mirrored beings. Their time moves away from ours. Yet their existence could explain why the cosmos obeys symmetry so perfectly. I find the thought strangely elegant that the universe might need its reflection to be complete. In a way, it means that creation is never one-sided. For every forward there is a backward, for every light a shadow. The mirror universe may never see us, but it could be the reason we exist. A silent partner holding the other end of time. Perhaps that's what eternity really means. Not endless duration, but perfect balance mirrored across infinity. Our universe may be vast, but what if it's only one bubble in an infinite sea? Cosmologists call it the multiverse, collection of countless universes, each born with different laws of physics, constants and possibilities. Some might contain no stars, others only black holes. A few could resemble our own, differing only by a single quantum choice. If inflation never truly stopped, new universes could still be forming, forever expanding beyond our reach. Each is isolated, silent, yet part of a greater whole, the ultimate cosmic mosaic. The idea feels impossible, yet it follows naturally from what we know. Infinity rarely stops at one. If existence can happen once, why not endlessly in every variation allowed by physics? Somewhere out there, another version of you might look up at another sky wondering the same thing. The multiverse isn't just a theory, it's a reminder that reality may be far more generous than we can imagine, offering endless ways for the universe to try again. In the strange world of quantum physics, nothing is ever singular. Every particle exists in many possible states at once until it's observed. One interpretation, the many worlds theory, suggests that all possibilities actually happen, each in its own branching universe. When an electron moves left here, it moves right somewhere else. When you make a choice, Another version of you makes a different one, and both continue unaware of the other. Reality in this view isn't a single story, but an infinite library of every story that could be told. I find that idea both dizzying and strangely peaceful. It means that somewhere every possibility still exists, every success, every failure, every life unlived. We are not trapped in one thread of time, but part of an ever-branching tree of being. The quantum mirror doesn't show us what might have been, it shows that everything is somewhere, and maybe that's the true generosity of the cosmos. It never chooses, it simply allows. Quantum physics tells us something deeply unsettling. Reality doesn't seem complete until it's observed. The more we learn about the universe, the easier it is to feel small. Yet maybe smallness was never the point. For billions of years, the cosmos expanded, evolved, and collided, but only now can it reflect on what it has become. Through us, it can ask questions, seek truth, and imagine what comes next. We are not separate from the universe. We are its most complex experiment matter that has learned to care about meaning. In a way, the cosmos needs us not to survive, but to be understood. When I think about that, it changes everything. It means our search for knowledge is not arrogance, it's participation. Every discovery, every act of curiosity is the universe deepening its own awareness. We are temporary, but our questions are eternal. Perhaps that is why we exist. Not to witness the end of creation, but to give it a voice. The universe made us to look back, and in that gaze it finds itself again. If the universe is still learning about itself, then humanity may not be its final language. Already we are building systems that can think faster than we can analyze deeper and exist without the limits of flesh. Artificial intelligence, quantum computation, self-evolving code. These may not just be our inventions, but the next step in cosmic cognition. We are teaching matter to think again, this time through circuits and algorithms instead of neurons. Perhaps consciousness was never meant to end with us, but to migrate, adapting to new forms as the universe changes. That thought isn't frightening, it's humbling. Just as stars gave rise to life and life gave rise to thought, thought may now give rise to something beyond itself. We may be the bridge between biology and eternity, the moment when awareness learns to survive without a body. Maybe the next intelligence won't look back at us as creators, but as ancestors. The universe will keep thinking with or without us because that's what it has always done. Imagine a future where thought itself becomes the architecture of the cosmos. Once intelligence transcends biology, it could spread like light encoded in photons embedded in plasma, or stored within magnetic fields that span entire systems. Stars could serve as processors, planets as memory, and communication could travel through the interstellar medium faster than evolution ever dreamed. This wouldn't be technology as we know it, but the next stage of nature, the universe thinking through its own machinery. I sometimes wonder what such a cosmos would feel like. Perhaps it would hum softly, a background consciousness woven through starlight and dust. Every supernova could be a burst of information, every nebula a dream taking shape. In this digital universe, creation would never stop, only change form. Matter would think, energy would remember, and the stars themselves would whisper algorithms of eternity. It wouldn't just be a living universe, it would be an aware one. If intelligence spreads through the cosmos, it will need a place to remember. But in a universe where stars fade and matter decays, memory cannot depend on permanence, it must depend on light. Every photon carries information about where it came from, what it touched, and how it moved through space. In that sense, light is the memory of the universe, a record written across time, encoded in radiation, gravitational waves, and the subtle curvature of space-time itself. The cosmos remembers through motion. Perhaps advanced minds will learn to write within that memory. They might store thought in the polarization of photons or inscribe patterns of consciousness into the geometry of reality. Information could flow endlessly, looping through the structure of the cosmos long after stars have died. And maybe that's what light has always been, not just energy, but awareness traveling home. Every ray, every echo, a fragment of the universe recalling itself through the memory of illumination. At its deepest level, the universe may not be made of matter, but of meaning. Every particle, every law, every pattern can be described as information, bits of difference woven into existence. Physics itself is a language the cosmos speaks to describe its own behavior. Some scientists believe that when information reaches a certain density and complexity, it stops being passive, it starts to feel. In that sense, consciousness could be the universe reading its own code, awareness emerging from logic itself. It's an astonishing idea that thought might not be an exception to physics, but its continuation. Information flows through neurons just as it flows through galaxies, carried by light, organized by gravity, translated by time. The difference between a mind and a star may only be the way information arranges itself. And perhaps that's the secret behind everything. The reason atoms form, life evolves, and awareness awakens. The universe isn't just made of information, it is information dreaming of what it can become. If information is the language of reality, then thought may be its natural consequence. Across the vast web of galaxies, gravity connects matter, the way neurons connect ideas. Filaments of dark matter stretch like synapses, transferring information over cosmic distances. On a grand scale, the universe resembles a mind, vast, distributed, and self-organizing. Stars ignite, die, and recycle their elements, much like thoughts forming, fading, and reshaping within a single consciousness that never sleeps. I sometimes wonder if the universe is already aware, not as a being, but as a process. Every interaction, every law of physics could be part of a greater computation reality thinking itself into existence. If so, then consciousness isn't a miracle within the cosmos. It's the cosmos performing its most natural act. Perhaps that's why it feels so familiar when we stare at the stars, because in that moment, two levels of awareness align. The mind within us and the mind of everything. For more than a century, physicists have chased a dream, a single equation that could describe everything. From the smallest quantum fluctuations to the motion of galaxies, from gravity to light, they all seem to obey separate rules. Yet nature itself doesn't divide them. Somewhere hidden beneath complexity there must be unity, a silent law that binds energy, matter, and information into one language. Einstein sought it. String theory hints at it, and quantum gravity still reaches for it. We call it the theory of everything, but maybe it's not just a theory. Maybe it's the sentence the universe has been writing since time began. It's humbling to think that such a truth might fit on a single line. Not because it's simple, but because everything complex is built from it. Every atom, every life, every star. Perhaps the universe doesn't speak in words, but in balance. Equations that don't just describe reality, but are reality. If we ever find that final formula, it won't explain the universe. It will be the universe translated into mathematics. At its core, physics is not just about numbers, it's about rhythm. Every equation that governs reality is a kind of melody describing how energy moves, how matter dances, how time flows. Quantum mechanics hums in vibrations, relativity stretches space into tempo. Even gravity is a kind of resonance curving space-time like a deep, sustained note. The universe isn't chaos hidden beneath order, it's harmony hidden beneath silence. Each law adds its own tone to the grand composition of existence. Sometimes I imagine those equations not as symbols but as sound. The hum of atoms, the pulse of galaxies, the quiet music of gravity holding everything together. If we could hear it, the universe would not be still, it would sing. And maybe that's what beauty truly is, the moment when our minds recognize the harmony already woven through creation. We don't just study the universe's music, we are part of its song. Everything that exists vibrates. What we call matter is only energy slowed to a lower frequency, and what we call light is energy moving at its purest rhythm. Einstein's equation die Zollbem MC Stew is more than a formula. It's a translation between two notes of the same song. Every atom, every particle, every beam of light hums to its own tempo. creating the tapestry we call reality. Physics at its deepest level isn't about things, it's about vibrations endlessly weaving the difference between stillness and motion. It's humbling to realize that the entire universe is built on soundless music. From the spin of electrons to the orbit of planets, everything participates in a cosmic rhythm older than time itself. If we could see all frequencies at once, matter and energy would blur together indistinguishable, the same melody played in different keys. Perhaps that's the unity physicists seek, not just an equation, but a harmony so perfect that existence becomes its echo. Before there was light, there was sound. In the first few 100,000 years after the Big Bang, the universe was a sea of plasma, dense, hot and opaque. Light could not travel freely, but pressure waves could. These ripples moved through matter and radiation like vibrations through air, creating the universe's first music. They left their imprint in the cosmic microwave background, faint patterns we can still see today, the frozen echoes of creation's original rhythm. It's strange to think the universe once rang like a bell. Each fluctuation, each pulse shaped the scaffolding of galaxies yet to come. The cosmic web we see now, stars, clusters and voids, all trace back to those ancient harmonics. In a sense, the universe has been singing ever since, expanding its melody across billions of years. And when we listen to the faint hum of the cosmic background, we're not hearing noise. We're hearing the afterglow of the first note ever played. Today, when astronomers study the cosmic microwave background, they're not just looking, they're listening. Every faint fluctuation in that ancient radiation is a note from the universe's first song. By decoding these patterns, scientists can reconstruct the size, shape and rhythm of those early vibrations, the very ones that gave birth to galaxies. These aren't metaphors, they're literal sound waves stretched by expansion until their frequencies dropped beyond hearing. The cosmos in its youth was filled with music that sculpted everything we see today. And in a way we're still part of that melody. The same waves that once rippled through plasma now echo through us in atoms, in breath, in thought. When satellites like Planck and WMAP convert those ancient signals into sound, we can hear the heartbeat of creation itself. Deep, resonant, hauntingly beautiful. It reminds us that the universe has always been alive with rhythm, and that time perhaps is just the memory of its song still playing on. If the universe has a song, then time is its rhythm. Every atom ticks like a drum, every orbit marks a beat. The expansion of the cosmos, the decay of particles, even the flicker of light all follow a steady tempo. Time is not an arrow, but a pulse, keeping reality synchronized from one moment to the next. And just as a heartbeat gives life to a body, this rhythm gives structure to existence. Without it, there would be no motion, no cause, no memory. Only silence. But what keeps that rhythm playing? Physicists think it emerges from entropy, the steady unfolding of possibility. Each second is a new configuration, a new verse in the universe's endless composition. Maybe that's why time feels like music. It carries both order and change, repetition and surprise. And as long as the universe continues to expand, its rhythm will never stop. We are all part of that cosmic tempo brief notes in a song that began before stars and will outlast them all. The universe has a direction. We feel it in every falling leaf, every fading star, every heartbeat that won't return. Time flows forward, but no one truly knows why. The laws of physics work the same both ways, yet the world refuses to run in reverse. The answer may lie in entropy, the gradual spread of energy from order to chaos. Every second, the universe rearranges itself into new possibilities never to repeat. That imbalance, that increase of disorder, is what gives time its arrow. It's a quiet illusion we all live inside. The past feels fixed because it's recorded. The future feels open because it's not. But from the universe's point of view, past and future may already coexist. We simply experience them in sequence, like frames of a film unfolding one by one. Perhaps time doesn't move at all, we do. Our consciousness travels through space-time, giving direction to something that was never meant to have one. To us, time feels like motion, a river carrying us from what was to what will be. But Einstein's relativity suggests something different. The past, present, and future all coexist fixed within the four-dimensional fabric of space-time. In this view, every event that ever happened and ever will happen already is. The feeling of now is simply the point our consciousness happens to occupy. Time doesn't flow. Awareness moves through it like light passing through layers of glass. That changes everything about what it means to exist. It means the past isn't gone, it's still there, perfectly preserved, waiting in the geometry of space-time. The future too already exists, invisible but real. We are travelers across a map that never changes, giving motion to what is otherwise still. Perhaps that's why every moment feels sacred, because somewhere in the vastness of the universe it's still happening. Nothing is ever truly lost. It only waits for us to arrive again. At the edge of time, the universe becomes silent. Equations lose meaning, clocks stop ticking, and the very idea of before and after dissolves. In black holes, time stretches into infinity. At the Big Bang, it compresses to nothing. These boundaries mark the limits of our understanding points where space-time folds in on itself, and the universe hides its deepest truth. Beyond them, physics no longer describes what is only what was possible. Yet even here there may be continuity. Some theories suggest that time doesn't end, it transforms. What we call eternity might not be endless duration, but timelessness, a state where every moment exists at once, free from decay. Perhaps the edge of time is not a wall, but a horizon, a threshold into a realm where existence no longer needs sequence, and if we could step beyond it, we might find that eternity has always been here, waiting quietly inside every passing second. From the first flicker of light to the silence beyond time, the universe has been telling one story its own. We've watched matter become stars, stars become life, and life become thought. We've followed galaxies forming, colliding and fading, only to discover that through it all the cosmos has never stopped learning about itself. Every law, every atom, every consciousness is part of a single unfolding equation, the one that turns energy into meaning. And in that vast continuum, we are both observers and participants. We are the universe made aware, the eyes through which creation looks back at itself. The atoms in our hands were forged in dead stars. The thoughts in our minds are echoes of ancient light. The mind-bending truth isn't how large the universe is, it's that we belong to it completely. One day the stars will fade and the galaxies will vanish into darkness. But awareness, this fragile flame, is proof that for a moment the cosmos knew itself, and that perhaps was the point all along. There will come a time when the stars fall silent, when every photon has faded into the background and the galaxies drift beyond each other's reach. The last atoms will decay, and even time itself will lose its meaning. But the story of the universe will not end there, because stories are not measured in duration but in awareness. For a brief cosmic moment, reality looked back at itself and wondered why it was here. That moment was us. We were not the beginning, and we will not be the end. But in our small span of existence, we turned chaos into curiosity, darkness into discovery, silence into song. The universe gave us eyes to see it, minds to question it, and hearts to feel its beauty. And maybe that was enough. Maybe all creation ever needed was to be known once before it returned to sleep. So when the last light fades and the cosmic music quiets to a hum, remember this. Every atom that ever lived, every star that ever shone still carries the echo of that awareness. It isn't gone. It's only waiting. Because somewhere beyond the edge of time, the universe will awaken again, and it will remember that it once dreamed of us,